is at the bottom.
Because it's further away from its source.
Rubbish.
Wait, what?
He
Professor
said,
Phil.
I'll translate, nuh-uh.
Nah, it's a powerful argument.
There's going to be a lot of nuh-ahs going on soon, and it's not going to be from me.
Shut up. You're dumb. You're probably the dumbest person in here.
Tell us why the Earth is flat.
Demonstrably.
It's not
Tell us
why
where.
the Earth
How,
is
how
flat.
did you discover that the Earth is flat?
Don't
Measure
speak to
flat.
me.
I
Where did
woke
you-
up and I walked out of the house and it was flat.
And you think just by looking at it, knowing that, given that the size of the Earth, that you just think it's automatically flat?
Why should I think otherwise?
Are there any reasons why you could be wrong?
Why should I think otherwise?
Answer my question. Are there any reasons that you could be wrong?
Yeah. Yes, exactly.
Right?
There could be wrong, but we start with that axiom, right?
Yeah. So
And what we see is what we get.
looks flat to you.
It looks flat to everyone.
Therefore, the
Everyone.
whole Earth is flat.
So that's a rationalization. So you're using like a rationalization. It could be flat. This experience could be real, but
Right, good.
there's
That's good.
reasons why it couldn't be. So, that's your rationalization. So bring some like meat to that bone.
That's good. We're getting somewhere. Could be flat.
Could be. But on first impression, that's what it is.
That's excellent. So let's drop this is flat business. All right.
Well, I mean, we verified it after that. You said, where did you get the idea in the first place? And I gave it to you.
What did you do?
Well, there's been laser tests. There's been measurements. There's,
Really?
those sorts of things.
What
Yes,
laser
really.
test? What controls did you do for the refraction?
How would you control for that?
I'm asking you the question.
What controls were they done? Well, they did a horizontal pan. They did horizontal panning, and they also did vertical tilting of it to see and to measure how much the angle at the other end changed.
Garbage.
Garbage.
Oh.
Okay, so Mike Kavanaugh actually gave an interview about this with Nathan Oakley where he described the entire experiment. Have you ever watched it? You ever heard what he said? Mike Kavanaugh actually had more degrees than you got.
I've watched that garbage show many times, and it's all rubbish.
Listen,
Nuh-uh.
this was just an interview. This wasn't like his show. It's an interview he did.
What else have you?
No,
got?
you could email them and ask them. They are a public nonprofit.
All right, let's take it from here. So let's talk about your flat Earth. Is the North Pole in the center?
Maybe.
What do you mean,
North
mate?
Pole. What do you mean by North Pole?
How much time do you need to work it out?
I don't know. What do you mean by North Pole? Even within your model, there are several. Geographic, magnetic. Which one are you talking about?
Let's talk about magnetic West Pole.
Yeah.
Hey, why is Phil telling us
Greenland.
to look into? Why is he telling us to ask about flat Earth? Why aren't we asking about the globe right now?
Because I want to know about
Measurable-
flat Earth. That's
no.
why.
Phil, you don't know about the measurable curvature of the globe.
I want to know
Much
about
less
flat
asking
Earth.
any questions about flat Earth right now.
I gave you one. Your
Ask about
response?
the globe.
I'll ask whatever questions I like. Now you just tell me
You need
what
to
makes
direct
you
those
think the Earth
questions
is
to the
flat.
globe. The globe
You're the
is
one
in
who thinks
question
the
right
Earth
now.
is flat. Explain why you think the Earth is flat.
I just told you, and you not on it.
No, Phil. I'm sorry, Phil. No.
I've got a couple
You're
of
not going to
maybes.
come in here and ask questions about flat. You need to figure out if the Earth is a
I'll
globe.
come in here and I'll ask whatever questions I like.
Stop talking, Phil. You need to ask questions about the globe first. Is there any measurable curvature found on this globe of the one that makes the positive claim that there's measurable curvature? Where is this measurable curvature at? We don't have any.
I want to know about why you
No,
think
you don't
the Earth
want to
is
know.
flat.
You need to know about the globe first.
No,
Establish if the globe is the actual paradigm, and then you
that's
can ask
got nothing to
questions
do
about
with
flat
whether
Earth.
the Earth is flat or not.
You need
Just
to
tell
ask
me
That's what he's
questions.
trying to get to. Sorry, Miggy, you're very quiet in the background.
You
But
must have an idea why.
Professor Phil, Professor Phil,
Yeah, I just
you're
told
asking
you
a
why.
question. Yeah, you've asked a question, you've been told why, and Miggy's also trying to tell you why.
want to know
And how does the North Pole's existence, non-existence, whatever, demonstrate the profile of the Earth? What does that got to do with it?
I'm trying to work out how you think the Earth.
What does the pole have to do with a curving surface?
I'm trying to establish what does the Earth look like in your
And
mind.
I'm trying to figure out how that just isn't a red herring, and how you jumped off the laser measurement to the North Pole, which has nothing to do with curvature.
I've already established that you think the Earth is flat because some laser experiment that
laser that was actually 7. They were done in 2 different locations. 2 at one location was 3 weeks apart. They took meteorological conditions. They panned the laser from left to right from a reference target through 3 other targets. Do you even know any details of the actual test? Or are you just not eyeing it with complete ignorance?
I have watched several of these things. Yes.
No, it's not a video. It's actually a report that's in PDF form.
He watched it though.
I watched some late that was done on Jeranism's show or something like that.
I don't know where Jeranism does or doesn't do.
All
right. So apart from what's your problem?
Now, just tell me about Antarctica. What's that like?
Never been there. Never been there. So we're not going to talk about a place I've never been to. I want to know what your problem with laser transit is.
Australia?
No. But I want to know what your problem, because you're just hand waving it away and not addressing it, and you're just going to talk through me.
Have you not? You've said you've not been to Australia, can you talk about Australia even though you've not been there?
I'd have to probably speak to an Australian and get some better information.
Yeah.
What the hell is this?
I don't know. Some kind of sophistry, man. It's a lot of bollocks.
Is this some type of Elmer Fudd sophistry about you ask people where they've been and you want to go there, and why don't we talk about some place you haven't been? What is your scientific evidence for your spinning ball space monkey religion?
We're not talking about the ball. We're talking about...
Oh, we're not. We better not, because you don't have any.
So,
yes, there's plenty of evidence that the Earth is spherical.
The fuck?
I want to know what evidence there is that the Earth is flat.
Well, wait a minute. Isn't the Earth
It's not a ball.
observably flat? And even Neil deGrasse Tyson says it. So is it depending on you to prove that it's not flat?
Let me just have a look and see if I can't dump an image for you to have a look at.
God, here we go.
So, check this out. We established that the Earth is flat as a logical axiom because it's self-evident that that's what it is. Okay, the evidence to the contrary needs to be provided. So you can keep saying, what's the evidence for the flat Earth? The evidence is just the first impression of what we experience. Now it's up to you to show evidence that our experience is somehow false.
There's plenty of evidence that the Earth is definitely not flat.
Right, let's have it one by one. Let's go.
Oh, for instance, ships going over the horizon.
Hold tight. Sorry, that's a claim to physical geometric location. Hold on. That's a claim to physical geometric location, as in physical horizon, for things to hide behind physically. The horizon's demonstrated to not be physical and apparent, so therefore can't be physically hiding things and can't be used as measurements to base any geometry on.
It was complete word salad. Rubbish.
How did you account for refraction?
Pardon?
That was complete rubbish.
What part of that was rubbish? Slowly.
You don't like salad.
Okay. Which part of that was rubbish? Which part specifically?
Please explain to me how it is that the ships go over the horizon bottom first.
Can be for a number of reasons, but your claim is physicality of the horizon, which it isn't. It's apparent.
Wrong.
How did he account for refraction? And
Laughing won't help you.
Listen, I'm laughing because this is an honest joke. So if we show ships go over the horizon where it can't possibly be the horizon that the globe says it is, at some shorter distance, then what's the reason for that?
There could be all sorts of reasons why you see the horizon in a different place.
No, I'm talking about you see the horizon obstructing a boat bottom first, and as it gets further away, eventually you don't see it. If you see that on some shorter distance than what the globe predicts, so say the globe predicts 2,500 feet, the horizon is, and you see the boat disappearing, but instead of that, you see that happen 5 times closer at 500 feet. What is the mechanism for that?
It won't happen.
Okay.
Wow.
Let me direct your attention to live stream voice text.
That was dope.
No.
This is recorded, right?
Yeah.
Yes, always.
Yeah.
So I'm going to show you a better. That's just a GIF, but I'll show you a better video I got. So there's a lady named Sky Free. Well, I mean, it's 30 seconds. You don't have to review it now. So the GIF actually just shows it. It's in a. I don't know why that's not him to me.
I can't see what you're talking about.
Okay, there's an animated GIF in the live stream, so it's color corrected to increase the contrast. So this is a camera height of 2 inches. The globe predicts the horizon from 2 inches is 2,500 feet away. This lake is only 600 feet long, and this boat completely disappears beyond the horizon. But the horizon, it's not at the horizon yet on the globe, so how does it disappearing?
Let me show you now exactly.
And I showed it full color. This person, this girl, Sky Free, and her boyfriend have replicated this about 20 times on a couple different lakes. They've had boats with flags, boats with lights on it, just lights, a bunch of different combinations, and they can just get these little RC boats to just vanish into thin air. Somehow. But this lake is only 600 feet long.
Let me show you.
So we know why this happens, right? This is called total internal reflection.
No, it's got nothing to do with the curvature of the Earth.
No shit. Really?
That's the point. You realize he just showed you the thing you said
Let's just
won't happen, right?
Let's
Hey, Phil, buddy boy. You realize he just showed you what you said isn't going to happen, right? Won't happen? He just showed that to you. You have any rebuttal to that?
Yes, I'll show you in a second.
Okay. Let's look at one image of what? This is the physical location of the horizon, and it's physically blocking the bottom of this object that I'm going to show you. This is it. Is it?
Okay. Look at the buildings. Where's the bottom of the buildings?
The same place that boat is.
Where's the boat?
It's the end of the diffraction limit.
We're talking about many floors, not a little boat.
We're talking about a boat in a little lake that just did what you're showing us the building is doing.
We're not talking about something that might
be many. But you're trying to be cute by saying many floors, right? So all that matters is the subtended angle. So you could say 20 floors, 30 floors. Depending on how far the building is beyond this, right? Like, so a 1 meter wave, a 1 meter.
Do you want to explain where the?
I'm trying to, but you're talking too much, right? So say this horizon is like 1 kilometer away, right? And the building is 10 kilometers away. A 1 meter wave, 1 kilometer away is going to block 10 meters at the building. So you could say, where's all these floors? It doesn't mean anything.
Right.
Right? So just like my thumb can block the Empire State Building if I hold it in front of my face, doesn't mean anything. You're trying to just mix and match absolute sizes to some some apparent size.
Where's the pedigree information on? Where's the pedigree information?
Yeah, like how far away is the building? Is it high tide, low tide? Is there a tidal bore? I mean, like.
Yeah, we want detail, Mr. Scientist. We want some pedigree information with your photo here. Not just here, look, where's the floors at her? Right? Some pedigree information. Observer height, distance to the buildings, sort in that vein.
And you want to know.
How did you control for refraction?
That's my question. Wait a minute. That's my question. What's sinking? Anybody can tell me what sinking is?
So I know what sinking is.
Yeah, but we're diverting
So
from the question, right?
What is it? What is sinking? Tell me what it is. What is it?
This is where refraction, where normally you've got cold air with warm air, but when you get warm air with cold air, you get sinking. Okay.
What is sinking? Now, what is it? If you used to see it, what does it
What
look like?
the hell?
This is
Word salad.
Okay, have a look at these wind turbines.
That was upset.
No, we're sticking to your buildings.
Rubbish, mate.
I want you to look at the wind turbines.
No, we're sticking with your buildings before we get to the windmills. Why don't you answer his question?
I don't
Answer
care
his question. He asked you what sinking was.
I told you what sinking was. This is where refraction causes things to appear to sink, right?
To sink.
Appear to sink behind what?
Can you please have a look at the wind turbines?
No. Sink behind what? Sink behind what?
Whatever you're looking behind. Whatever you're looking at.
So what am I looking? So if there's a horizon out there, is it sinking behind the horizon?
If the conditions are right, that can happen. Yes.
Okay. Do you have the pedigree information on this photo so we know what the temperature variation of the water, the air? Do you have all that?
Have a look at the wind turbines.
No.
That means
we can see the image.
That would be a no then, right, Phil?
No, I don't have the specifics.
Okay, thank you.
Oh,
Have a look at the wind turbines, please.
okay. What about
Got specs for those.
Where's the
We need
bottom
observer
of the
height.
turbine?
We need observer height and distance.
Why is it that the distance to the wind turbines,
What's the distance?
the further away they are, the more they sink?
What distance? What's the observation height? What's going
Because
on?
shit gets smaller with distance. It's called
you can
second
see that they're
grade.
not getting
Angular
smaller.
size change with distance. So,
Sorry, but they're not getting smaller.
Sorry. So they're not getting shit's not getting smaller with distance.
You can see that that compared to the ones that are closer, that's not that much smaller.
Oh, there's not
Where are
that
the
much
bottoms?
smaller. Okay,
Not
so
that much.
Stop fooling yourself.
oh,
Where are
okay,
the
stop
bottoms?
fooling myself. Okay, what is the observer's height here, and how far is the horizon away?
I don't know exactly the distance, but as far it would
So
be
it's
in the
an empty
region of
plane
about,
then?
No,
6
this
to
is
7 miles.
empty. You're just what you're doing. You're showing photos and then wrapping your fairy tale story
I
around it
want to
with
know
no
where are
evidence.
the bottoms.
With no evidence. What does
Stop.
empirical mean?
Stop fooling yourself.
What does empirical mean?
Calm down, man.
Fooling yourself.
You sound big
Where
mad.
are the bottoms of the
What
wind
does
turbine?
empirical mean, Mr. Tapping on the whiteboard?
I don't give a damn about that. Now
So-
you just tell me.
So what you're doing
Where
is
are the bottoms?
you're
of the
wrapping
wind
your fairy tale
turbine?
story around a simple observation,
for you,
which
is
is
it?
basically religion.
I told you there would be a lot of nuh-ahs going on.
Oh yeah,
and it
you're the
comes
one that's
from you.
stating them, Mr. Rubbish.
He also said it wouldn't be you saying it, but that's clearly
I told
been
you there
proven
would
wrong.
be a lot of nuh-ah. And
Yeah, you've held up. Yeah,
5 of them.
I'm not going to
you
let
held
you go.
up. You
Where
held up
are the
swimmingly, my
bottoms of
friend.
the wind turbines?
Hey, Prof. You just provided 2 pictures with no information, which means nothing. So you have provided nothing here so far.
Let's go back to the
Where
RC
that?
boats. Let's go back to the
Why
RC boats. Obviously, RC boats are a lot smaller than those wind turbines. So, yeah, that's why. Yeah,
No, where are the bottoms of the wind
Where's
turbine?
that boat?
Where's the bottom of the RC boat? Answer that
Where's that boat
first.
at?
Okay,
boat-
now make your RC boat a little bit bigger. There's your answer, Professor
The
Phil.
wind turbine is huge. They're hundreds of feet high. Where are the
Rubbish.
Rubbish.
Word salad.
Oh, Professor Phil, you really don't look around you very much, do you?
I'm afraid you don't. I think
no,
you do.
No, no.
You
Do you want
are
to
in
explain
your
why?
little-
Would you like me to explain why?
Stop for a second.
Would you?
You
Okay.
have decided to
Preach to me,
join your
brother.
little cult.
Oh,
And
here we
no
go.
evidence. will
Join
Here
us.
comes the
I'm trying to-
psychoanalysis.
Just trying to back up what I just said about how you don't look around you.
Now, please explain to me about the. Okay, actually, I've got another one for you to have a look at.
Why
Curvature?
are we explaining your photos? Shouldn't you be the one explaining them?
He can't. He
Let's have
wants us to
another-
explain them.
Would you go up to a complete stranger and then ask them to explain something for that which they have never made a claim for? Are you batshit insane?
You're the one who said the Earth is flat.
Are you batshit insane? Yeah, but I'm not here to explain your photos. You are.
Is the Earth flat?
You are. You
Tell me-
explain your evidence, sir.
Tell me if you think the
Could I
Earth
just
You
interrupt here?
explain
Sorry,
your
Quantum.
evidence, sir.
One of the things Professor Phil always says, Quantum, is that you never say the Earth is flat. He's just stated that you say the Earth is flat. So which is it, Phil? Does Quantum Eraser say the Earth is flat, or doesn't he?
I've no idea. He's there now. He can say it for himself.
Oh,
You just said it, didn't you?
Well, he
Phil.
can say it for himself. He's there.
Phil, why do we have to explain your evidence? Does that make any sense?
Why don't you just tell us if you think the Earth is
Why should I explain your evidence, counselor?
flat?
Bailiff,
Why don't you just tell us whether you think
grab
the Earth
him
is
by
flat or
his
not?
short little pee-pee and throw him out on his neck.
Come on. Is the Earth flat or
You're a
not?
numpty dipshit. You, sir, are a numpty dipshit. You're asking us to explain your evidence.
Just tell me whether
Is the
you think
globe a
the Earth
circle?
is flat or not.
Is the globe a
That's
circle?
shit insane, sir. Sorry. That's why Indio left. He said, fuck this. You're a moron.
Is the Earth flat or not?
Your sister is.
This really the best argument you got, bro? Prof, this is the best
Wait a
argument.
minute, I've got a photo to show you.
You have any measured curvature at all? You got any of that on hand?
Oh, yes,
on
plenty
deck?
of that.
Oh, plenty of that.
We're not
Provide us
claiming-
with that, please.
We're not claiming.
Because that's the positive claim, right? Is that the Earth is
Yeah, of
some
course.
type of fucking magic water balls flying around in a vacuum, right?
Yeah.
You got evidence for that?
What magic water? I don't know what magic water balls you're talking about.
Magic, bro. Magic.
It's the one you believe you live on.
I'm not a believer in magic.
Oh.
You're just a believer in balls. How they become balls? Well, that's not your business.
Yeah,
is
yes,
it?
I certainly believe that.
How it is a ball and curved?
Exactly.
That's none of your business.
You're supposed to be a prof, and you got like low-level globers actually putting up a better argument than you. This is pretty
Really?
sad.
Yeah,
This
really.
is embarrassing.
Not embarrassing
Yeah,
for me.
two pictures. First of all, you claim something would never happen. 2 seconds later was proven that dead wrong. Then you provided 2 pictures with no information whatsoever and asked us questions about it. As if we're supposed to explain your
Wrong on
nonsense.
every count.
Also, he hollered obscenities.
Wrong on every count.
This is real corny, bro. This is like old and busted right here.
Hang on, I'm just looking for a photo for you so that you can.
You did come in with that, like, ready?
This is actually got some. This actually does have some figures with it. So, just a minute.
But how are you going to explain the RC boat, though? Are you ever going to try and explain that?
It's just too inconclusive for me to make any comments about that.
Come, dude, listen. The RC boat has disappeared bottom first, and you've claimed that's the reason why the Earth is a ball. Explain that, dude. Unless you're just a believer. Rubbish.
Rubbish.
I like this rubbish today. It's funny.
You asked me about the Earth being a sphere. Of course, you know that there's satellites, don't you?
Boats disappearing bottom first as evidence. Are you ever going to explain
Yes,
that?
I have. I've already given you 2 pieces of evidence.
Yeah, you're saying it's inconclusive, but this is your evidence that the Earth is the ball.
I'll give you another one just as a matter of
Then what's
interest.
going on with the RC boat if that's not the curvature of the Earth?
I'm not interested in that particular thing.
You're not interested in your own fucking explanation and fucking evidence that the Earth is a ball.
It's inconclusive. I told you that.
It's your evidence. That's your problem, mate. Fix it.
The photo is poor and inconclusive. I would not use it as evidence.
Oh, you've got problems.
This man.
You're the one who's got a problem. The problem is you, who's stuck in a cult.
No, mate. I'm asking you to explain your evidence that is contradictory. And you're saying it's not, and you're saying you're not interested in this. So whose problem is this? It's your evidence, bro. So it's your problem. You have to fix it. Just gonna ignore it and talk about fucking stars and shit that doesn't. It's not relevant. That's not
Yes, of course they are relevant.
Stop lying to yourself.
Stars are very relevant.
We just have someone just like to hear himself freaking talk. That's all we have.
That's the best they got.
You poor victim.
No, you're the victim.
Is that really the best they got, man? Is there anyone else we could bring in better, more productive? Because this one's kind of a dud.
I can feel the love.
Brenda.
Your laughing is really not helping you.
Well, at least with Brenda, I could maybe learn something.
Well, you can learn something. You ask me some good questions, and I'll answer them for you as much as I can.
Why is the RC boat disappearing bottom first in that video?
I don't know about that particular thing. I told you it's inconclusive. You can't make any.
All you got to do is answer the question why it is disappearing bottom first. Because it can't be the curvature of the Earth, so you must know why, right?
I don't.
So you're just gonna ignore this very thing, this very experience that your eyeballs can see. You're gonna ignore it and go look at some fucking math. You're not going to explain what you're seeing, right? It's how ignorant you are, bro. Being ignorant, and you don't even know that. Really, how old are you, mate? This is embarrassing. That's what I mean.
No,
embarrassing yourself. I'm embarrassed for you.
You don't need to be.
Well, then you don't need to be concerned about these victims either. Don't worry. Go help with the coronavirus or something. Go help with world peace or something. Oh, we're all right here. We're fine. We're not going to die for believing the Earth is flat. Just like you're not going to die for not being able to explain this RC boat disappearing bottom first. You don't have to, right? So why should we explain anything to you, Phil?
Well, you're the one who said the Earth is flat.
You're the one sticking your nose in the wrong freaking hole.
You still hasn't said that the Earth is flat.
The Earth is not a ball. Can you understand that?
I want to hear
go
you
from
say
there.
Flat.
Flat is not a shape, you fucking idiot. Is the globe a circle?
How about just keeping it civil?
Is the globe a circle? Answer the question.
It's a sphere.
Is it a circle? Yes or no? Then stop asking people if the Earth is flat.
You know exactly what I mean by flat.
You know exactly what I mean too. So why the hell are you asking these silly questions?
Have a look at the have a look at the photograph.
Why are these RC boats disappearing bottom first?
Have a look at the
not
photograph.
The curvature of the Earth. Answer the question, man.
I'll have a go at
that. I'll have a go at that, Professor Phil.
I want you to have a look at this photograph that I want.
You know that photo in the upper left-hand corner is a black swan.
Ooh.
Have a look at
you numpty dumbass dipshit.
Tell me where look at the one on the.
Tell me how far. Give us the pedigree information here. Observer height and distance to the first platform.
Just tell me where are the platforms gone?
Where are the platforms? Where are the platforms?
The photo on the left-hand side.
Right there. I see both of them.
The photo on the left-hand side.
Please explain this. Okay, I'll explain it. What is the observer height and what is the distance to the first platform?
Well, apparently I heard this, that the observer height was very close to the water, so something within a couple of feet.
Okay, no, it's 1 foot. And how far is the horizon away from him?
Well, apparently that was, if you're looking at the bottom right one, the one at the rig over there, looking on the left-hand side, on the left-hand top, that would be approximately 3 miles.
That's not 3 miles.
To the horizon.
No, it's not. That's 6.21 miles. It's at the base of Platform Hill House.
And then, no, it's not.
At the base of Platform Hill House, Phil. You numpty dipshit. This is a black swan photo.
The base of that platform is missing. Okay.
What?
Now,
where is the horizon?
The horizon would be approximately 3 miles away.
It is not 3 miles away. It's 6.21 miles away. Welcome to Flat Earth. Snacks are in the back. Bathrooms on the left. You're a numpty dipshit.
DJ's on the way.
Now let's have a look at the photo that's on.
DJ's on the way. Do you know that I have this photo in every single Black Swan presentation from the beginning? You're going to talk through me. I'm going to mute your dumb ass.
I don't care. You obviously.
Fair enough. So, you see this photo right here? On January 1st, 2020, this appeared in my Black Swan presentation. But you're such a numpty dipshit, you don't even know it. And you're such a numpty dipshit that you posted another Black Swan photo because the observer height here is 1 foot and the horizon is 6.21 miles away when it should be 1 mile away. So, and you're both flat and curved would look very similar. Really? Are you invoking some type of refraction here? Looming? What the hell? Oh my God, I got to take them off mute for this. What the hell is looming?
You don't know what looming is?
No, I want you to cite it right here for me.
Okay. If you have a look at the diagram on the bottom right,
I want you to cite looming. Thank you.
Looming is the first industrial machine that was ever created to make.
Now, hold on. Let him. I want to hear if he knows what looming is. I want the definition.
Okay, have a look at the photo.
No, I'm not having a look at the photo.
I created that diagram. It's my own handiwork.
Shut up. What is looming?
Look
what
at the
is
diagram.
looming? You claim looming. What is looming? What is looming? You will not pass go until you define it and provide citation for your claim, sir.
So light bends as a result of the temperature gradient.
That's not looming.
That's what looming is.
No, it's not. You fucking moron. Nope, it isn't.
I don't care what you say, you fool.
Looming. You're going to have to shut you up. So that's your definition. I told you it was wrong. You're a fucking idiot. You're a numpty dipshit. Looming from Andrew Thomas Young. The appearance above the horizon of a distant object that would normally be hidden below it. That is the definition of looming. In fact, this definition of looming is in-fucking correct. But even within this wrong definition, even if I give it to you, you already train wrecked your argument. Because this is talking about objects in relation to the horizon, not the horizon itself. You're an empty dipshit. Demonstrated yet again. So, welcome to Flat Earth. Snacks are in the back. Bathrooms on the left. Chocolate?
TJ's on the way.
Really, you think that actually worked, don't you? It may have worked for your little...
It's already a wrap.
That might have worked
already a wrap.
Set of victims.
It may have worked with Neil deGrasse Tyson, but don't try that shit on Phil, right, Phil?
That probably worked for your little set of victims.
That'll work on Mick West. That won't work on you because
you're a scammer. You're a grifter. Have a look at the bottom photo.
You interrupted the DJ. Please don't do that again.
Have a look at the bottom. Don't please me, mate. I'll do it as I please. Now, have a look at the bottom.
We'll see about
that. And by the way, my laughing is doing me very fucking well, numpty. So how would you know what was well for someone else? Did you learn that in school?
Oh, I can tell this guy never listened to his teachers or his headmaster. So, yeah.
Probably abused as a child, I'm just a guess.
I like to tell bad jokes. So, yeah, sorry, man.
I mean, he could have cited his own source. Maybe it would have been different than QE's and it would have made his argument better, but
he did.
Apparently he wasn't prepared.
Right. Decided to unmute me. That's good. Now we can get somewhere.
Right. To the horizon, right?
I want to have a look at the image. I want you to have a look at the image that's commonly referred. Actually, Sasha put it up. Thank you, Sasha. Sasha put up the image of the rigs where there is looming. Now, there's actually evidence for this. There's looming and towering, and there's actually evidence for that. And the evidence for that is very, very clear. First of all, the first one where we're looking at looming of the horizon. So you can tell that because that usually happens when you have a look across the water and you can see the bands of colors, of different colors. Like you can see it's really dark towards us, closer, then gets lighter, then gets lighter again. That gets this yellowish color. You're
an empty dipshit. Sasha's photo train wrecks your
Would you mind just being quiet just for a minute?
You're a dumbass. I used this photo in my explanation of every single black swan presentation I've given. You can see the horizon if you use your off-center vision. You can see the horizon. It's right off the bow. So this is looming, but according to your definition, it's not the horizon that looms. It's things in relation to the horizon, Dr. Phil. Do you understand this, numpty dipshit?
Will you stop being a coward and stop?
Do you understand what I just said, numpty dipshit?
I understood exactly what you said. Now, can you just stop being a coward?
So you said the horizon was loomed. That is not. That is incorrect.
The horizon is loomed. Everything.
No, that's not the definition, Dr. Phil.
Listen, looming. I explained to you what looming was.
No, you didn't. You made it up. No citation. You're done.
Light benzene gradients, bro. That's not a definition.
Yeah, that's not a definition.
You can see that this.
The definition was provided though for you. Phil?
Just shut up. Unless somebody else wants to talk, then I'm done with his numpty dipshittery. You're just making shit up.
Do you hang out at Jim Panda's server, Professor Phil? Because I think it's poisoning your brain, your mind, man. Going there.
Yeah, he's certified.
So QE, you want to deprive?
Don't speak to me ever again.
You want to deprive?
Yeah, apparently so, he does. Yep.
He does.
All the time.
We do.
Apparently, he's mistaken. He doesn't know what server he's on. I think he's lost.
How important are you, QE? That you're the one who calls the shots.
Who tells you that? Like, why do you think that? Do you know who's all in here? Like, we call our own shots, mate. Do you? No, you don't. You don't call your own shots. People tell you to jump, and you say how high. So don't talk about us, man. You don't know us. You won't even listen to us. You won't even explain fucking RC boats and why they disappear bottom first in your goddamn evidence. Nobody wants to hear your shit, your rubbish.
I know, you'd think he'd be able to muster up his intellectual might, conjure up something like very powerful.
Well, stop muting me and then you'll actually hear some stuff.
Okay, sure.
By the way, audience, the reason that you can't hear my voice is because anytime
mute him. Thanks.
Who the hell does he think he's talking to?
Audience.
Audience.
I talk to the audience.
He's the fucking secret king. Audience, they're muting me. I've got secret fucking knowledge. I need some fucking parts of them, and they're not letting me do so. I'm being a fucking victim. Fucking victim, gamma, fucking secret king bastard. Fuck off.
Yeah. Very narcissistic community, I would say.
Thank you for unmuting me again.
Oh,
I don't know what that serves except just wastes.
Well, I couldn't quite get that. What did he say?
Professor Feller, you got any proof of the flying spinning ball? Stop addressing QE. He's above your intellect, dude. Yeah, you're not a professor. You're a clown.
Mm-hmm.
Just me. I am way below his level. So just me, you're
What's
way
your
below
name?
my level, but at least I'm closer to you.
What do you call you? What do you call yourself?
Batman. You can call me Batman.
I don't care. You can whatever you want me to.
Well, you want me to call you the Professor, Professor Phil? Then you call me Batman.
Sure,
All right,
I'm happy to do that, Batman.
Okay.
Sure.
Thank you.
Okay, Batman. That's fine. Batman, I just want to ask you a question. Batman, have you ever looked up in the sky and had a look at those objects that are moving?
You mean those lights? Yes, I have.
Yeah, those lights.
I grew
You've
up
seen
looking
them?
at the Milky Way my whole life when I was little.
Yeah, so the ones they move. Apparently, they move from the UK to
the sun
Australia in about 40 minutes. That's the sort
There
of
we go.
speed that they get.
No.
Now, what about them? What about lights in the sky?
Who put them there?
Who put them there?
Yeah.
What kind of question is that?
Not you, Phil.
Well, if you believe in the heliocentric model, right, then NASA put them there. But if you believe that you live in a reality where your eyes observe, and then probably something like a creator created them and put them there. I mean, if you look at how complex and sophisticated life is and what requirements they need, yeah, there must be a creator that put them there. Yeah.
Years ago.
Or are you going to call me stupid because I believe in a God? Is that where we're going with this?
You're happy to believe.
Are you going to try and say what flat Earth is a faith and the globe is? Is that where you're trying to drive this? Huh?
No, not at all. I'm just trying to get to establish what those Starlink satellites are. Have you
ever taken a look at the ocean? You know, that flat horizontal thing. I mean, you're up there in the sky. I'm just trying to bring it back down here to the thing we're talking about.
You told me that you saw those objects. What do you think they are?
They're lights. That's the first thing I see them as, are lights in the sky.
Who put them there?
I believe in my religion, in my spirituality, that there is a God. And he probably put them there.
The last lot went about 2 or 3 days ago. Did God do that?
The last what?
Wait, what?
The last lot of Starlink satellites went about 2 or 3 days ago.
What the fuck is a Starlink starlight?
He's not talking about the stars. He's talking about the SpaceX nonsense Starlink crap. That's what he's talking about. You guys are talking
Bro, I see airplanes. I see airplanes at night, and they look like stars moving in the sky. Is that a goddamn satellite? Go ahead, explain it.
They don't.
Why? How the fuck do you know which one is a satellite and which one is a plane? Because you've got a model and a fucking website that you check. Huh?
Because the plane is
fucking tell me what those things are in the sky, bro. They're fucking rocks and gas burning in the middle. You sound like Timon and Pumbaa from that fucking movie, The Lion King.
Be quiet for a minute. So you can track those things in the sky from the UK to Australia in 40 minutes. You think a plane can fly that fast?
Some of these stars and lights I see at night, right? They move. And some of them are planes. But you're saying they could be satellites, they could be rocks, you know, like.
Just answer the question.
They're lights in the sky, right?
Do you think a plane can move from Australia to the UK in 40 minutes?
Why the fuck would you ask me that? That's not relevant to what we're talking about.
Phil, that's a loaded question. You can't even fucking prove what you just said. That's number one.
I can.
Number two, no, you can't. Number two, I asked you before. I asked you this question a long fucking time ago. And you said, yeah, you believe that from Mars, that rover's sending fucking pictures, sending transmissions through fucking millions and millions of miles. And you're a professor of fucking physics, and you yet to answer my fucking question. How is it fucking possible to get telecommunications from fucking Mars to Earth to get high resolution fucking images? Please explain. Fucking asshole.
I think that is the right energy for you, Professor. So you go ahead and that will take care of you.
Professor, you've heard of the inverse square law, right?
Motherfucking, yo, bro, you don't even know a fucking thing about physics, and then you fucking pretend to clown fucking physics. You fucking cunt.
You think that can help you?
Professor, what's the inverse square law?
You think that kind of language is becoming of a person like you?
Professor, what's the inverse square law?
Stop fucking crying. Hey, listen, Phil, stop fucking crying. This is real shit. You're pissing everybody fucking off.
Nobody's trying here.
But when you're
If
in
you
a
were-
fucking
if you-
corner,
if you were
you're
in
gonna
my
start
class, I
fucking
would've
crying
kicked you
about
out.
my language. You fucking bitch.
All right, Vlad. Let's let Hank ask the question. What is the inverse square law?
Yeah, what is that, Professor?
You don't know what the inverse square law is?
No, please enlighten me.
Is that the reason you're asking me the question?
Well, I'm just wondering how a little battery from Mars' surface could send a signal strong enough 1 million miles away if I can't get signal at my curb from my Wi-Fi router.
Where is everybody?
On Earth, right?
We're waiting for you to answer the question, Phil.
You don't know what the inverse square law is. You seriously don't know.
He just gave you an example.
You don't know
right?
that.
Just asked you a question, mate.
Okay, so things will reduce by the square of the distance away. That it's further away.
Right. So the power source is staying the same, but the further you go away, it
2,
decreases
4,
the signal strength.
16, 64, and so on. Okay.
By the time you get to 1 million miles away, how much power is actually hitting the Earth? From the Martian rover, how much?
You satisfied?
What's the signal strength? What's the signal strength from 1 million miles away?
Now, I still want to know what those objects are in the sky that move from Australia
Are
to
you
the
serious,
UK.
Phil? Are you not listening to Hank talking to you, Phil?
No, I
Please.
can't hear what you're saying.
He's asking you, after 1 million miles, is that signal going to reach Earth? If you and the inverse square law, then how can that signal from Mars reach the Earth, and how much power is required for a signal to reach the Earth?
Yeah, show us the data. Show us the data on that. How much power at 1 million miles?
The only reason.
No, show us the power. Answer the question. Show us how much power at 1 million miles with that battery. Thank you.
I'll come back to that.
No, you won't.
Where are you going now?
I'm very happy to come back. Now that I've got
Now, Professor, you do it now.
Yeah, can you answer the question, Professor Phil, please? We're all waiting. Can you provide citations for that as well? Thank you.
Is anybody ever going to answer one of my questions?
How much power at 1 million miles?
I don't know off the top of my head. I told you I'll come back to that.
Go get it. Bring it back. Bring it back.
I'll come back when I'm in my good time.
Well, okay, how far is Mars? Because we're only talking about 1 million miles, and the moon is supposedly 250,000 miles away. So Mars is tens, if not hundreds of millions of miles away. How far is the sun, right? So come on, man. This is a crazy, impossible thing, and you're saying you're going to come back to it, right? Like, we're telling you this is fucking crazy, impossible, and you're saying, nah, I'll come back to it. What the hell? First, you won't answer the question with the RC boats, and now you won't answer this question. What the hell, Phil? Where the hell are you going?
Mars is about 60...
Never.
Almost 60 million miles away.
And you can't even answer how it can work with 1 million miles. But yeah, okay.
When that's just another number. Is that average? Is that its furthest distance? Is that its closest distance?
That would probably be the average distance, around about 60 million miles.
Probably. Okay.
Can you show us the telemetry data, please?
So it's between about 33 and 60 odd million miles.
Can we see the radio telemetry data? Thank you.
33 and 66. Wow.
If you want specific things, I'll write them down, and then I will be able to get them for you.
You coming in here like you know what you're talking about.
I came here to ask you some questions.
Well, you haven't answered not one question. Why don't you start with answering?
I came here to ask you why you think the Earth is flat.
You came here to straw man us, bro. Come on, man. You were not stupid.
It's such an easy answer.
Phil, I came here to ask you why you think the Earth is flat.
I asked you that specific question months ago. I asked you. You said you were gonna come back to me, and you have yet to come fucking back to me. You know, and you remember I had a fucking conversation with you, and you still
I don't
cannot
even
answer
know
the
who the
fucking
hell you
question.
are.
And don't tell me you're gonna come back to it because I know for a fact you won't be able to answer that fucking question. You're talking to a guy that fucking finished electrical engineering. You stupid fuck. You done improving sewer rat fucking
You're an
piece of shit.
engineer?
Go
What?
fucking die.
All right,
fool.
Vlad.
I'm done.
You're
I'm
an
done.
engineer.
Take a breath, Vlad.
What? Did I just hear that? You are an engineer and you think the Earth is flat.
Why? Why? What's wrong with that, Phil?
But
You still haven't explained the RC boats, bro. You can't even explain the RC boats and why they disappear bottom first. What's the problem? He's an idiot. You can't even explain the RC boats. You can't even explain how things can travel millions of miles. Who are you calling?
It's not even explaining it. It's just admitting that that's what we see.
I teach engineers. Did you hear that?
No.
What? Well, I'm Batman, so I win. Anyways.
Okay, Batman. I teach engineers. You said
I'm Batman, so I'm cooler than you, and I have more credibility than you, all right, Phil? Because I'm Batman. You know, everybody knows Batman.
Engineering, we do orbital mechanics.
Yeah, that's a fairy tale, bro.
Is it really?
You got lots of maths there.
It
You can't even prove your Earth is a ball, so how can you have your stupid orbital mechanics?
You said I can't.
Huh?
You think you live on a spinning ball in space that's never been proven? You don't have a measure of curvature, axial rotation, or vacuum of space.
Who said there's no measure of curvature?
Why are RC boats disappearing bottom first, a couple of inches off the ground? Why is that RC boat disappearing?
Phil's still here.
Have a look at that photo.
Yeah.
Remember, it's the same RC boats.
I was waiting for this.
This is the same RC boats that right before he said won't disappear. Said it won't happen.
You said
that was you, Phil.
The Earth has not been measured. That's what you said.
But why do you?
Well, hold on.
My friend wants to talk to you.
Building a store.
Do you understand that there's for instance, in last November, we put up a satellite called Cartosat 3. Cartosat 3 is designed to map the Earth.
How far up is that satellite, bro? How far up is it?
509 kilometers.
What part of your
No,
fairy tale thing?
Yeah, don't entertain this guy.
Yeah.
Don't entertain him. Give me a second. I had to restart the live stream.
Every time that satellite makes a sweep, it measures the Earth.
No, it doesn't.
Yes, it does.
What does it measure curvature? Does it? So if it measures curvature from up there, then where can we measure curvature down here?
Measures the diameter.
All right, stream restarted.
I can give you some very good experiments if you're actually interested in the truth.
No, we're not interested in what you're going to provide. Here's what we're going to be interested in, Professor Phil. You're going to have to demonstrate to us how the Earth is a globe, like the way they claim it is, right?
I told you that. I told you that.
Well, you told somebody, but it wasn't me. I wasn't here.
He said,
he
said RC boats disappear bottom first. That's what he said.
So
I take it that you, Mickey, right?
Okay. Yes, I'm Miggy. Remember?
Okay, Mickey.
We've had a
Nice to
previous conversation. Nice to meet you too. Now, let's get to the business of proving that the Earth is actually a real globe instead of it being something that a positive claim that can't be verified. So measurable curvature, when has it ever been done that somebody has got measurable curvature, either in ancient times or now, Phil?
Well,
doesn't
now,
matter. It doesn't matter. I don't really care.
By satellites.
Right, but when did they start actually saying that it was a globe with measurable curvature? When was this done?
Thousands of years ago.
Okay, so who's the first one that did it? Go ahead.
I don't know who the first one was, but I do know about Aristotle.
All right, so we haven't established in ancient times, but now go ahead and tell me how they've done it today. Go ahead.
Satellites, I told you.
Which satellite?
Well, there's satellites that take partial photos and stitch them together.
Okay.
Sun synchronous satellites, and there's also satellites that actually take photos of the entire Earth.
Okay, which specific one, Phil?
Himawari 8, for instance.
Okay, so the Himawari 8 is the one that's taking this measurable curvature picture, we can measure the curvature of Earth with this satellite. Is that
Yes,
right?
of course.
Okay, so how are we doing that?
You have a look at the photograph. And compare
Okay,
it
do you
to
have one?
Yeah, compare it to the distance of the satellite.
Do you have one?
Of course.
Okay, can you please provide that evidence in live stream voice text? And then after you do that, provide the evidence as to how the Earth curve was measured using this photo, please.
Just a minute.
Okay.
To send a satellite, they would need the radius value. So how did they get it before the first satellite?
Well, we're going to see what Phil has to provide as evidence, and obviously this is going to be something that is going to provide the measurable curvature, right?
Of course.
Okay.
Just a minute. I'll get this photo down for you.
Excited.
Sure hope he's bringing an actual measurement. Like,
So for anybody that's actually in here who's going to ask any questions about the globe, this is Professor Phil. If you guys haven't heard him, he's been on here for a while now, and he teaches students that go to his class. So he should know, if anybody, if you're in here and you're a glober, he should know more than anybody the questions I'm about to ask him, and provide sufficient evidence for the positive claim that the Earth has measurable curvature. There's two more follow-up questions, but we'll start with this one because it's a pretty easy one. So,
sure.
Who's Aristophanes again?
All right,
I thought it was
hold off on the questions for any diversions that might occur. We're going to pinpoint him down to this very specific one.
I'm excited.
Okay. So now we got an image here. Everybody, can you take a look at live stream voice text? Phil just provided an image here from Himawari 8.
Yep.
All right. So now the next step is, how do we establish the measurement of the curvature of Earth from this image? Go ahead.
So when you have a look at the edge of it, you can see that's curved, can't you? It's not a square, is it?
Well, no, you go ahead and provide to me how
just
this is.
Just answer my question.
No, I'm getting the listen. I'm getting the information from you, how you provide evidence for measurement of Earth curvature. That's all I want to know. I'm not. Okay. It's not a debate. It's just for you to give me information as to how it was established that this image is the measurement of Earth curvature. And so go ahead and follow up with giving me the way they measure the Earth curvature using this image.
Yes. So we know the distance to the satellite that took this image to the camera.
Okay.
Okay. So because we know the distance to the camera to that, we can actually look and work out what the diameter of this ball is that you're looking at.
How'd they know how far it was?
How did you validate that picture was actually taken from a satellite? How did you validate that?
Well, we're not even there yet, rags to riches. Right now, he's going to demonstrate to us how measurement of Earth curvature can be achieved using this Himawari 8 image. So we're going to let him finish, telling us how.
It does look like a ball, doesn't it?
Well, it appears to be a circle. I can't tell from an image if it's a 3D shape.
Okay, so you can actually see, you can tell that it's got a circumference, right?
As what it looks like. Looked like a circle to me.
And it's got a diameter, right?
Obviously.
Okay, good. All right. So we can establish that at least you can see a circle anyway, right?
Yeah, of course.
Okay, good. So you agree that we can establish what the radius of that circle is? We can establish its diameter. We can establish its circumference.
Right. What we're doing here, though, is drawing circles and then doing a bit of maths. That's what you're doing, right?
It's a photograph.
Right, but it's not a photograph, though. I think that's where you're mistaken. No. So you're saying hang on. You're saying that this satellite is taking snapshots, like photographs, and it's not sending data to somebody who receives this data and then interprets that data and then makes an image out of that data. You're saying it's a straight photograph like you would any camera, and then you get film out of this camera. Is that because that's what the audience is hearing right now?
Not film, it's data. It's
right. Camera. So yeah, but it's not. You're not going to get images like that. You're getting data according to the globe. I'm just following the paradigm so that we can get everything kind of down the line as to how this is being established from the Himawari 8. It's not a snapshot. This is data. It's data that somebody's receiving and then interpreting it as a image.
No,
it's not.
It's a 16-channel camera.
Okay.
And of course, just like any digital camera, the digital information is in terms of digital information that's sent via radio to the receiver.
All right. So, how did this satellite get into a place where something cannot exist? This medium cannot exist.
What medium can't exist?
The vacuum of space, of course.
What vacuum?
Well, when you actually send a satellite into low Earth orbit, it has to leave the Earth's atmosphere. And by way of a rocket that's going to use a parabolic curve around the Earth 3 times so it could gain escape velocity so that it could actually leave the Earth's atmosphere so that it could drop these supposed satellites there. So how is it that this medium, the vacuum of space in which this satellite is in, actually exists?
It'd probably be useful if you just stop using the word vacuum and just say space. That'll be fine.
Well, space is something. Yeah, space is something that I could define as something between me and you. So, to be a little bit more specific, right? When you actually leave the Earth's atmosphere, because they would consider there to be a specific stopping point, right? The Kármán line. After you exit the Earth's atmosphere, then you're actually in low Earth orbit. So, in order for
it's actually not specific.
Well. So this medium that this medium that this satellite is in, taking this image, how do we know that medium exists?
We put satellites there.
Okay, so you're telling a story right now that something is going there, but there's no way that anybody that's listening could verify that information because this medium supposedly is in a place that cannot be in reality.
Why not?
Because we have pressure here, the air that we're breathing, and it's adjacent to the supposed low pressure system, which is what you consider space, but I call it the vacuum of space. That's what they call it. So how can we have a high pressure system next to a low pressure system without the gas dispersing into the available space? With this supposed satellite? Why not?
Yeah.
Well, we're defying the laws of nature, sir.
Which law of nature?
Entropy. What are the law?
Oh my God!
Are you not a professor? Are you not a professor? Like, I mean, this should be something that you should be able to tell your students.
To establish your knowledge.
You teach kids? Are you serious?
No, I don't teach kids. I teach adults.
If you have a high pressure system next to a low pressure system, what would happen if you do not have it? If you do not have that high pressure system, becomes uncontained from whatever container it's in. It will disperse.
It depends on all sorts of forces that are involved.
Well, it doesn't depend. This is what's going to happen always. It will disperse into the lower pressure system always.
Really? Why does Why doesn't
Professor Phil, if your air conditioner is on in your house and you open the door, what's going to happen? Yes, Professor Phil, you need to keep the door closed.
Wait a minute. What forces are in play? What force is containing the gas?
Let's just finish with Miggy, please. Okay.
Go ahead.
Miggy's doing a good job.
So have we established how we can have that? Go ahead.
And may I also add that I like the way that you do talk to people because you're a respectful person. So I'll continue talking to you.
Go ahead.
Okay. So Miggy. If you consider at the bottom of a mountain, you have a much higher pressure than at the top. Why is it that why doesn't the pressure at the bottom the gas at the bottom rush to the top of the mountain?
gas is always in motion. It's always in motion, right?
That's true.
Okay,
that's true.
So
why does it rush to the why at any time you go to the top of the mountain, you're going to need some apparatus to breathe?
It's a graduated system.
Yes,
right. So we're talking about the dynamic system in which we live. The air that what's that?
Yeah, you said. Sorry, I didn't. I shouldn't have interrupted you. You said that always. You used the word that higher pressure would always move to lower pressure. Always, you said.
Yes, if it's not contained. If it's not contained.
If it's not contained. And yet you have just admitted that at the bottom of the mountain, the high pressure doesn't move to the top.
Okay, we're still talking. Yeah, we're still in a container right now. Okay. So the graduated system that you're in right now is contained. So this is where we start with. In order to have pressure, you need to have a container to start with. So you can't have pressure without a container. Who said? This is just the laws of nature.
No, it's not. You just made it up.
No, it's not. No, I didn't make it up. How can you? Okay, so how can you attain Professor Phil? How can you attain pressure if you do not have a container?
What do you need the container for?
To attain pressure.
You've got the mass of the gas.
The mass of the gas.
No. The mass of the gas doesn't bring the gas back. Gas disperses in all directions, and the gas doesn't stop itself from going anywhere.
Overall, the gas has mass.
No, it doesn't, Phil. That's just
Sorry, but your is not going to help.
What's up, Adam?
Evening, guys. Phil. That's naughty, isn't it? That's.
I want to talk to Mickey, please.
Individually, if you was to add up, then let's ignore the misnomer of mass. If you was to add them all up, you could say collectively they had a mass, but that's not a gas, is it? Where are you grabbing them from? Why are you trying to attribute collectiveness to an individual particle?
You don't think I could measure the mass of gas?
No, we did this before and you ran off. At the point, where you was going to inflate so much helium into the balloon that it was heavy enough to weigh, even though that wouldn't weigh it because it made it liquid. That point, and you ran off then.
I don't know what you're talking about.
No. Pain, you often try to forget.
Okay, Miggy, do you want
to... Point being, mate, yeah?
There's more stuff to discuss with Miggy. Okay?
Carry on.
Yeah.
Sorry. I just noticed backflipping. I know Adam to be very trustworthy, and I can probably take on his point that you haven't uttered something and running away, and now you're running away again. The question was pretty valid. Yeah, I know.
I'm still here.
Okay, thanks, mate. Just let's see if we can talk, and the other people can just be quiet while we talk. All right?
Sounds good with me.
Okay, excellent.
But this is an open forum, so I'm just letting you know right now. So somebody jumps in.
Yeah, all right. So, Miggy, I'm not.
Phil, I think respectfully, mate. The point when people jumped in was, and people are being respectful, was when you said something so outrageous that it really you shouldn't be carrying on the conversation.
Why can't Miggy deal with that?
Without it being challenged.
Miggy's pretty smart. He can deal with that. He doesn't need
You're not going to convince Mickey. Whatever sales technique or method you're trying, you're not going to convince Mickey. Talk about it here. Adam is as calm as Mickey. You can talk to both of them.
I'm not trying to convince anybody. And I certainly have no delusions about convincing you.
Yeah, but as he said, it's a public forum, isn't it? It's a public forum, and Mickey was doing...
I'm just trying
obviously you're not here to learn what we've discovered, right? You're here to try to convince people that you're crazy for believing the Earth is flat. That's what you've been saying when you first got here. Say it. That's what you've been doing.
All right. Let's try and get it back on point at least, and get the side bit. But let's get it back on point. Let's destroy that So massive gas. Whoever wants to take that, Adam or Miggy, I don't care. Massive gas.
Well, it's not just anybody. I'm talking to Miggy. Is that okay?
Yeah, you can talk to me if you want, but we're still on that particular topic you brought up. So
yeah. So I just want to explain to you. So Miggy, let's just establish this. I'm here to explain what I think and what I believe. Okay. So I'm not trying to convince you. Is that okay?
Go ahead and tell me what we were on a point right now, so I think it's good to kind of keep going where we're at.
Yeah, so I agree. So what I wanted to explain to you is why I think that the gas doesn't disperse into space.
Go ahead.
Okay. All right. So all gas particles, molecules or atoms, the reason that they move around is because they have energy. Otherwise, they wouldn't move. They need energy to move. So what happens is the higher up you go, the more of that energy they lose. So they get less and less energy. They move around.
Why?
That's bullshit.
Can we just have Miggy?
Can we?
No. Why?
Why? Go ahead, Adam. Sorry.
Evening, John. You all right?
Yeah, he's fucking full of shit.
So the further up, I'm telling you what I believe. You don't have to accept it.
Shut up. You're the dumbest person in here. Let Adam speak.
And now that you won't accept it.
Phil, we didn't say it's not true. We asked why. What's the reason for you?
I'm trying to explain all of that.
Well, then it would be reasonable just to have answered the why point initially, wouldn't it?
Just wait till I've finished what I'm saying.
No. You said the gas molecules lose their energy. Where do gas molecules get their energy from? Kinetic energy?
The heat from the sun.
The temperature, right?
And the temperature of the ground.
The temperature, right? So as they go up higher, have you heard of the thermosphere by chance?
And bouncing from other...
Have you heard of the thermosphere by chance?
Let me explain why
What is the temperature of the thermosphere, Phil?
Let me explain why.
No, you're not explaining. You just contradicted yourself.
I'm not interested in talking to you. You told me not to talk to you.
You just contradicted yourself. You are a numpty dipshit.
Can I just finish talking to Miggy, please?
Why?
Because I want to.
You're either dumb or you're lying.
Can I speak to Miggy, please?
Go ahead, Miggy. Miggy's going to tell you the same thing.
All right. So it doesn't matter if Miggy tells me the same thing. I just want to speak to Miggy. Okay.
All right.
All right. So as gas particles get higher, they lose their energy, and they lose more and more of their energy. And the higher they go, the more that gravity actually overcomes.
Phil, quick question, Phil. Is energy rate proportional to height? Or is it just coincidental that at some points when you're a bit higher, they might have less energy, and at some points they might have more energy when they're even higher, and then later on, less energy? Or is height a relationship in some way causative, you might suggest? Is that what you're implying?
It's certainly a correlation. Yes.
Correlation. What, is it a straight linear correlation, or is it a wobbly line?
No, it's not.
Or
it's
is it
not
a curved line?
It's curved. It's not linear.
No, if you look in chat, someone's put it up for you. It's a wobbly line.
It's not linear. Okay. Now,
I didn't say it was, but I just proved that your point and your understanding is incorrect.
Yeah. So at some point,
wholly incorrect.
So there is a
carry on.
There is a point where the
Phil, are you just going to walk? Are you just going to walk past that? You're not going to acknowledge what Adam said to you.
I'm trying to explain to you what I think. You can accept it.
What you think is what? Oh my goodness! What a shocking.
Nobody cares what you think.
Fine, that's fine. You don't have to.
Yeah, but nobody cares what you think. If you have something, what you empirical, say that. Whatever I can speak about Brad now, man, and who cares?
I want to speak to Miggy, please.
You can speak with Miggy. Can you give some argument? Speak with Miggy.
I'm not speaking to you, whoever you are.
You're not speaking with me, really?
No.
Let's get some orders back to the conversation at least.
So Miggy asked me a question, and I'm trying to answer.
Okay, you was wrong now 5 minutes ago, and you don't want to concede. You want Miggy.
I've never been wrong. Okay.
Miggy, are you still there, buddy? Do you want to hold this guy's hand?
Right. So now we're talking. Yeah. Now we're talking about why gas is not escaping the globe Earth paradigm, right? You're saying because it loses energy as it's going up.
Yeah, and eventually, gravity overcomes the little energy that it does have.
All right. So gravity becomes the container. Is that what you're saying, Phil?
If you want to put it that way, I'm happy with that.
All right. So at that point, we're talking about no gas escapes because of what you described.
Definitely not. Gas escapes all the time. Gas does
escape.
Yes.
So does it escape or does it not? I'm sorry. Does it escape or does it not escape?
It does.
So it does escape.
Yeah.
As an analogy, Phil, then is this gas molecule
about 90 tons a day?
What's that? How much?
About 90 tons a day.
Okay, so I'm really right now. I'm just listening to what you have to say about this because I'm still thinking about what Adam said, and they seem to have a really good point. But so you're saying 90 how much? 90 tons?
Tons, yes, per day.
All right. So who's measuring this, Phil?
It's like, this people, lots of people who monitor atmosphere and climate and stuff like that.
Oh, sorry, it's a bit vague. Was there anybody specific that does this? Like meteorologists? Like
NOAA. NOAA. Just answer. That's his answer.
Well,
no, I want him to. Who? NASA?
Yeah, NASA would be one of those people who have the resources to do that. Yeah.
What is the apparatus they're using to actually find this information out? What are they using to detect? So that information.
I don't specifically know how they do that.
Okay. So we don't. Okay, sorry. We don't know how they're getting this information, but we just know that they're giving it to us about 90 tons a day.
That's what they say. Yeah.
All right, but we don't know that. Is that what you're saying?
Well, I could have a look at their paper that describes how they do it and see if I agree with it. But at this stage, I've got no reason not to disagree. I've got no reason to disagree with them.
All right. So, well, I'm going to roll back.
It's theoretical. It's theoretical. Yeah, it's not a measured amount. It's a calculated amount based on the trajectory of hydrogen and helium atoms, which the analogy you're painting is it's a bit like the guy in the desert when he fires a bullet up in the air and up it goes until it reaches a point, and you're saying it hits that point and then back down it comes because gravity makes this container that it bounces against. It's this complete total loss of kinetic energy that causes a return and an opposite vector.
Well, Adam, it almost sounds like Phil's. It almost sounds like Phil.
Whatever you said obviously points to the fact that you know nothing about projectile motion.
All right. So from whatever he said, Adam, it sounds like he's saying that on the globe Earth paradigm, we got some air actually escaping, right?
Yes.
I mean, it's actually leaving.
No, I wanted to get to that. That's fine. It's fine. But they're the black swans, aren't they? They're the exceptions to the rule, aren't they, Phil? But most of them follow the pattern I've just described, apparently. Yeah. But you get some of them, that magic number that you pulled out your arse, the amount per day that escapes the atmosphere. They're the ones that break the general rule of the new way in which gases behave, which is against the second law and against gas behavior, but has to be the way gases must behave if we live on a ball. Is that not correct?
There's nothing against the second law of thermodynamics, if that's what you're talking about.
What? So would you say that?
Show me gravity affecting the kinetic energy of a gas molecule, then.
Oh, any time. Cool the gas molecule down until it becomes a solid.
gravity affecting the kinetic energy. It's got to be slowing it, hasn't it? It's got to be stopping it, escaping.
Yeah, that's easy. That's easy.
Show it me then.
Yeah. So the consider the gas the amount of gas concentration at the bottom of a mountain compared to the gas concentration.
Concentration. Come on, that's rubbish. That's terrible.
You can say that as much as you like.
Disingenuous. Disingenuous.
You can live in your little cult as much as you like. Won't change anything.
Some might say.
Won't change anything.
I'd say.
You know, it's weird. You think we live in a cult, and you think you don't live in a cult, even though all your beliefs are just beliefs. You know, that's
it's
weird.
a pretty big cult, then, isn't it?
All right. So where the where the air escapes, is there supposed to be a boundary? Is there some sort of boundary where the air is actually leaving and escaping into?
There is no fixed boundary. Those molecules that do, and particles that do have escape velocity, will just keep going.
Yeah, it is.
Because there's nothing to stop them after that.
So, don't see any reason not to believe there's.
Well, you just said that gravity was stopping them. Even if they escape the magical point where the bullet returns, the point where most of the particles go, what about those ones that do manage to get past? Surely they get pulled back eventually. Don't they get sucked to the moon on the way?
Once they have achieved escape velocity, they'll keep that velocity as long as they don't bump into something else.
And how many times a day?
What would their escape velocity be?
First law.
What would their escape velocity be?
Around 17,000 odd miles per hour.
17,000. So somehow, unlike all their friends, their other mates, other helium mates, who got slowed down to 0 and then start heading back down, they managed to keep going at 17,000.
They never to 0.
Yeah, they managed to keep doing it, but their mates don't. Is that right, Phil?
Yep, they might have been. They could be in the, because you're quite right. Somebody else, I think it was QE, mentioned the thermosphere. So in that area, any particles that are affected by the sun or whatever are quite likely to reach have enough escape velocity to get away.
So the thermosphere is likely to heat particles enough up to give them the kinetic energy to carry on their journey away from the Earth.
Some of them, yes. Others.
Once they've left. Once they've left, some of them. Why only some of them? What about the others that receive the same kinetic energy?
For whatever reason,
why don't they?
If for whatever reason they don't have escape velocity, they won't leave the
I don't think your mum finished your fairy tales here, Phil.
You can think.
What kinds of reasons?
Wait. Did you say for whatever reason?
What kinds of reasons?
Well, hang on. I think Adam. Yeah,
heating, bouncing into other molecules.
Well, that's not a loss of kinetic energy because it's an elastic collision. So there'd be no change in their kinetic energy, would they, Phil, if it collided with another molecule? Carry on.
No, you're just talking rubbish. Learn some physics.
He's not talking rubbish. Wow. You're supposed to be a physics teacher. You're supposed to be a physics teacher. Everyone knows this.
Oh, my God.
That's why he's exasperated. Adam is the most calm person I know, and you got him off the reservation because of that last statement.
Yeah,
you are so full of shit. I'm surprised that you know the difference between yourself and a pipe wrench.
Yeah, sure.
I'm serious. Yeah, everything he said was correct.
Yeah, right. Okay.
Yes, everything. Okay, and you should know that. Being a professor of physics, you should be teaching him. But he's teaching you.
He's not. He's an idiot.
I beg your pardon.
He's an idiot. Really.
I beg your pardon. I may not. Oi, daft lad, right? I may not have bothered in the route of academia, right, and sold my soul, yeah? But I'm perfectly well educated and I teach doctors, postgraduate degree levels, cheeky arse, right? Don't come here pulling your guns out because you got a professorship.
And I teach people.
You can take away the legitimate points where I've just, as Nathan would say, teabagged you, yeah? Unfortunately,
nothing of the sort.
as if pulling out that you've got
You've done nothing
some
of
kind
the
of
sort.
university education. What university is yours? What university are you affiliated with, Phil? Which two big university? Mine's the University of Nottingham. Yeah.
I'm not going to talk that much.
No, because you're going to be like the University of back of a cornflakes packet, won't it?
Sure, right, okay. Whatever you think, you idiot.
Well, that's what you get for China.
You tried pulling out academic guns.
Okay.
And if you want to go academic guns, I'll take you on. Because I've got just as big an academic gun as yours, little man. So don't try and obfuscate a point with that. It just shows how weak your argument is. Now carry on addressing the point that you were so admirably failing on.
Actually, no, I'm not.
So do you have a coherent rebuttal to anything Adam said, or just it's word salad?
You're a little cult.
Oh, just gonna cry.
Wow,
that's your problem, Phil.
That's pretty sad, bro. I mean, for a
carry on,
prof.
Let's carry on.
Made you sound like a
carry
Cracker
on?
Jack box.
I want to ask a question.
Cracker Jack,
So all those,
brother, we ain't
all those
carrying
metric
on. You're a
tons
moron.
lost a day, all those metric tons lost per day for 4.54 billion years?
No. We're back to the elastic collisions and what Adam said. What
That's a straw
Adam
man
said.
fallacy,
There's no net
Phil.
loss of energy. They're elastic collision. You said bullshit.
Is this what your flat Earth looks like?
That's a straw man
My
fallacy.
word.
God, here we go.
Fuck off.
But
Go back to your
What's
Cracker
wrong,
Jack.
Phil? Have you lost focus? Phil, you can't concentrate. What's wrong?
All he,
Yes or no?
all he
Is this what
said
your
in the
flat
last
Earth
two
looks like?
exchanges is, "Nuh-uh,
Yeah, that's-
he's a straw man."
Yeah, it's a straw man.
Is this
Yeah.
what your
Well,
flat
let's
Earth
just beat him about the head and shoulders, Professor Phil. Right? You looking in live stream. You looking in live stream.
Is this what
Introductory chemistry. And I quote, gas particles are constantly colliding with each other in the walls of their container. These collisions are elastic. That is, there is no net loss of energy from the collisions. Exactly what Adam said. This is introductory chemistry, sir.
Do you think the earth is flat or round? What do you think, brother?
Wait a second.
Brother,
do you think the flat guy? Shut up.
Oh, around, brother, you tell me now.
Hold on, I want Professor Phil to answer what has been put forward.
I'm muting everybody that's talking. Go ahead.
Is this what your flat Earth looks like?
Not a straw man.
Just answer yes or no. You can say yes or
no, not a straw man. So no, not that. Not any question to do with that. So back to this has been put forward to you.
No, I'm not interested.
Adam.
Answer whether you answer the question whether or not this is the flat Earth.
This is interesting. Why wouldn't you answer the question though, Phil? Is it something that is damning to the argument that you're trying to put forward? I don't understand. Like,
come on, it's a really good point, Phil. Why? What are the other reasons you've accepted that you might have made a mistake, that collisions with other gas molecules?
I haven't made a mistake.
A reason for a lot of kinetic energy.
I have not made a mistake.
They're going to gain that from the sun rays. So what other reasons are you suggesting? That's where we were before we went a little sideways. So let's carry on from there, Phil. What are the other reasons other than kinetic collisions?
Whether or not this is your flat Earth.
That's a straw man fallacy.
It's really weak.
So sad.
Yeah, it's a straw man fallacy. Nobody claims that, Phil.
Yeah, the short answer is no. Everyone's going to say no.
Nobody's claiming that. Nobody's claiming that, but we're still like we started off trying to figure out. We started off trying to figure out if the Earth had any measurable curvature, and you brought the Himawari 8 photo. So we were trying to. Right.
That's more than enough. That's more than enough.
What I was trying to ask is, how did the Himawari 8 actually get into that place that you said is actually there? Right? No, I'm talking about how does it exist in that location? Because that location
on a rocket, Miggy. It went on a rocket. That's how it got there.
No, I understand that the whole globe Earth paradigm and how things are told to us, how things happen. But I'm asking you, because supposedly you would be able to explain how gas pressure next to the vacuum of space is possible. And you were saying with your explanation,
I explained that to you.
You were telling me, but what I was getting to, and Adam and QE brought up some really good points, right?
No, they didn't.
So they didn't bring up any good points. You're saying that what they just put forward has nothing to do with what you're talking about.
Very little.
So it does. So that's what I'm trying to establish. So very little means that it does, right? It does have something to do.
They're trying to compare gas pressure down here on Earth, on the ground, compared to atmospheric pressure.
We're talking about individual molecule behavior. Individual molecule behavior and its microstates available to it at these points of juncture that you're imagineering, like the juncture of the vacuum of space. Yeah? What are its available microstates to it? What's its kinetic energy? What are the path routes? What's the probability? What that predicts is standard gas behavior. That does not fit in your paradigm. And we're asking you to explain what are the reasons then outside of that. Now, you postulated other collisions with other gas particles, which we explained to you patiently, that gas particle collisions are kinetic, so there's no exchange of kinetic energy. So we're asking again, what are the other postulations for your reasoning to oppose the gas behavior that you accept yourself? So what are the other reasons that's causing what can only be described as a generalized downward motion?
The most prolific reason why gas particles stay close to the Earth is gravity.
What?
Gravity.
John, I'll hand over.
We're not talking about close to the Earth. Adam was discussing high up in the atmosphere.
When I talk about close to the Earth, I'm talking about...
No, we're not talking about that. We'll get back to gravity here in a second. He told you, or you said, that the collisions of the molecules, they were losing energy. When Introductory to Chemistry already tells you that these are elastic collisions. I have the citation here about 50 times. Let me put it in here again.
I know the collision theory of chemistry. Thank you very much.
Yeah, it just sounds like you don't, sir.
Yes, I do. Much better than you.
Yeah. It sounds like it. You said they lost energy. This says that there is no net loss of energy from the collisions. They're elastic.
I know chemistry a lot better than you.
Yeah, you know chemistry. You don't know dick.
Degrees in chemistry.
You wouldn't know chemistry if it landed on your face, spun around, and whistled Dixie.
You're a goddamn fool.
So we're back to the net loss of energy.
Again, Phil, if we're going to do that, I have a degree in pharmacy. Like I said, I also advise on the postgraduate courses and educate at the graduate level, which is, I would assume, with your physicsy, mechanicsy background, means academically, my chemistry trumps your chemistry. Would you agree?
No, it doesn't.
I think it does, doesn't it, mate?
No, it doesn't. I've spent years.
Hey, I got real quick. I'm missing something here, Phil. You said that the gas pressure down at Earth is different than atmospheric pressure. Is the gas pressure that's on the Earth not atmospheric pressure?
Hey, do you teach at degree level? By the way, I'm not sure I'm talking to. Whoever just said that, they're above Phil's level as well.
I'm talking about gas pressure in a container.
You need a container for gas pressure.
Container.
Okay. Yeah, you do need. That's correct. You do need a container for gas pressure.
So where's the container for that's around the Earth?
Oh,
where's the container around the Earth?
Well, that's your question, surely. That's the question That's the question we're trying to get you to ask yourself, Phil. That's the reality you've got to come to. And when you realise the implications, when you realise the fundamental implications of the statement you just made and how it applies to not us, but your paradigm, you'll be on your way, son, won't you? Hey.
You said that there must be a container. You said that yourself.
That's correct. Where is it? You want me to show it to prove the necessary antecedent?
Yeah, I want to know where
it's a necessary antecedent. You know it's there, Phil. Yeah.
Where is your container? How far away?
Where's your bumhole? You can't see it.
You think that's clever, do you?
No, you think you're being Phil. You think you're being clever, right? With your false part. You think you're being clever. You're not. That's why I was being what's called in retort to point out the silliness of your question to me. That's why I retorted like that. You understand that? That's called intelligent humor.
Is there a container or not?
It was to show the silliness of your question. Yeah,
there is a container.
Yes.
Good. All right, excellent. Now, how far away?
Sounds like you were trying to prove some sort of a container yourself before, right? You were saying this word gravity.
How far away is the edge?
Reality.
Oh.
How far away is the edge of the universe, Phil?
Where is the evidence for the container?
The evidence is the gas pressure that we have here.
Yeah.
And how far away is this container?
Well, we don't have that measured. So the measured somebody has their mic open right now.
Has somebody
test one too?
Has anybody ever measured the distance to this container?
No.
I don't remember anybody making a claim to how far.
Nobody.
Whatever the fuck.
Nobody made a claim to that though. But there is a container because we have gas pressure.
But but I heard a claim before about gas literally reversing itself and coming back down due to something called gravity.
Where's the container between the top of the mountain and the bottom of the mountain?
There's like two sides of that coin, Chocolate. He's saying that some is escaping, 90 tons is escaping, but some of it is actually getting kicked back. Some's leaving, some staying. So it's not. This explanation was there is some leaving.
I told you you can accept it or not.
Yeah, he did say that.
Right.
He said they lose energy until gravity overtakes them, but the other ones that escape, they don't lose energy. How does that happen?
They're the what they call the Scotties, aren't they? Like from Star Trek, they're the Scotty molecules.
Yeah,
they're all the rest. They can't change the laws of physics. But these ones can, apparently. A metric tonnage per day loss. What a load of income.
Yeah, Phil, nobody made a claim as to where the container is. We just know we live in a contained system because we have gas pressure. But that's not what you think, is it? Doesn't matter. We have gas pressure. That's the proof we have a container. You, unfortunately, do not.
Evidence.
The evidence is the definition of gas pressure, Professor Phil. It's a necessary antecedent fact. So let's see if you can follow this, Professor Phil. Calm down and I'll explain it to you. Well, I'm getting a lot of feedback. Whose mic's open?
Yeah, exactly.
Whose mic is open?
The Himawari. The moon.
Hold on a second, Professor Phil. We're going to explain this.
400,000 kilometers away.
Hold on a second, Professor Phil. You said, where's the container? We don't have to worry about that. I'm going to explain it to you. You ready?
Sure. Love to hear where this container is.
Yes, it's a simple, consequent, necessary antecedent game. Just like filet mignon is the consequent, the necessary antecedent's the cow. You see, if it's already clearly established that to have filet mignon, cows must exist. So if someone slaps a filet mignon down on the table, then I know with absolute certainty that the cow exists without ever seeing or needing to see a cow or the data for the cow or the color of the cow or how long its tail is. Because it's a necessary antecedent. I'm not done yet, Professor Phil. You see, in this scenario, the gas and air pressure is the filet mignon and the container's the cow. Do you follow that, sir?
Yeah, such a straw man.
It's a straw man. How is it a straw man?
Fucking logic, dude. Are you fucking serious?
Totally unrelated.
You're like a fucking child and shit.
Wait, I want to hear how it's a straw man.
Total child.
Okay, how did he straw man? Like, what's it?
Completely unrelated.
How is that?
That's not what a straw man is.
How is it?
Poor Professor Phil.
I thought you were a professor. You don't understand basic logical fallacies yet?
I want to know, where is the container?
Phil, can you tell us?
He just gave you the example. He gave you the example like the filet mignon.
It was absolute rubbish. Now, there's no connection between the two of those.
It's up there. How about that, right? It's up there, dude. Just like your gravity is down there. Yeah, it's up there. You happy? Can we move on?
No, it's not. It's over there.
It's over there.
Over there. There. Over here. Over there.
So
over there.
Right. So he demonstrated to you that, with the filet mignon example. Why was it difficult to understand that if we have gas pressure, we would have to have a container, Phil?
Could this container of yours?
Yeah.
Could it be 100 million miles away?
That's a nice
If you want it to be, Phil, if you want it to be.
I'm just asking a question.
You just don't want to accept that you've been lied to, man. You just don't want to accept it. Because you have no reasons to not believe NASA.
Hold on. Where did you get that number from? My bad. Go ahead, bro.
Phil, what is the necessary antecedent? Hey, Phil. What is the necessary antecedent to gas pressure?
Certainly not a container.
Cowbell.
Wait, let me ask you. That's a professor, dude. Someone's going to need to get a refund on their tuition. This is crazy. What's the necessary antecedent to gas pressure?
Yes.
No.
That's the gas.
We need to get these sound bites, man.
Hey, what would you give one of your students if they gave you that as an answer on one of their papers? Your mark. What do you give your student when they say, "What's the necessary antecedent to gas pressure?" And they say, "Gas." Did you laugh at them, Phil?
All right. So what we're gonna do? So Adam, I think can we let QE kind of go through this? Gas pressure, because he brought this up, so I'd like for him to go through it for the audience, because the audience needs to hear this. Professor Phil made a statement that certainly not a container, and gas contains gas, but people need to hear this. I don't know. QE, did you want to go through this?
Yeah.
Okay.
We can go through it. It's at 19 minutes after the hour. What we're going to do is we're just going to define what gas pressure is. So from the chemistry department at Elmhurst University, it says the pressure of a gas is the force that the gas exerts on the walls of its container. From NASA, gas pressure. The molecules are in constant random motion and frequently collide with each other and with the walls of a container. Because the molecules are in motion, a gas will expand to fill the container. Since density is defined to be the mass divided by the volume, density depends directly on the size of the container in which a fixed mass of gas is confined. The last two are the heartbreakers for you, because it comes right out and says exactly what the cause of gas pressure is. Kinetic molecular theory explained by Boyle's gas law. Observations about pressure may be explained using the following ideas. The rapid motion and collisions of the molecules with the walls of the container causes pressure. That's force on unit area. Pressure is proportional to the number of molecular collisions and the force of the collisions in a particular area. The more collisions of gas molecules with the walls, the higher the pressure. And lastly, Chem Libre text, gas pressure is caused by gas molecules hitting the walls of the container. With a smaller volume, the gas molecules will hit the walls more frequently, and so pressure increases. So when I say that to have gas pressure, the necessary antecedent is container, I mean that it's inside the definition of gas pressure. Thank you.
Very nicely done.
Thanks,
Can you now go to the part that talks about the same thing with regards to atmospheric pressure, please?
Oh, atmospheric pressure is different than gas pressure?
Go ahead. Find some. So tell me where.
I'm asking you, would there be a difference between gas pressure and atmospheric pressure?
Yes.
What's the difference between gas and atmo, which means air, which is gas?
So when we talk about atmospheric pressure, we're talking about the amount of newtons of force that's acting on.
No, sir. You're going to have to differentiate. I'm sorry, you're not going to do this. You're going to have to differentiate the difference between gas and atmospheric pressure, sir.
Do you know what the formula for
gas and atmospheric pressure? You said they were different. That is a law of identity violation.
But John, maybe Phil, John, maybe I could ask for a point of clarity then. So when we're talking about these two different pressures, Phil, when when we're talking about gas pressure, we're talking about collision rate against the surface of the container or the sampler. Yeah. What's the difference when we're talking when we do that in the air and we have air pressure, atmospheric pressure? Are we using the same device and measuring the same amount of collisions?
Okay, so well, generally speaking, you would use a barometer, wouldn't you, to measure atmospheric pressure,
it's
right?
the same thing then.
Okay.
In terms of pressure, then it's the same thing. Within whatever measuring device you're using, it's the collision rate which equate to the surface of the container, because they've become part of the container, just like me and you are part of the container. We're part of the surface area of the container, aren't we? So with that in mind, then, what's the difference when we're measuring atmospheric or air pressure to any other type of pressure? Is there something different we're measuring, or are we just describing a difference in a kind of ideological way, or are we just measuring the molecules in exactly the same way?
So you're measuring the amount of force.
So are we measuring the molecules in the same way? Measuring air pressure and gas pressure, do we measure the gas molecule behavior in the same way?
Yeah, so your instrument is
yes
obviously...
Or no?
He just asked you
yes
a question.
Or no?
So
I'm
just to move forward, Phil, because it's important.
I'm answering it.
Yes or no? Is it measuring the same thing? The behavior of gas molecules?
You can make up your mind after I've answered it.
So you're not prepared to answer something that simple?
Why don't you just accept that I'll answer it, and then you can make up your mind about whether I have answered.
Phil, I'm more happy for the viewers to listen on such a basic question that a professor isn't prepared to give a direct answer on that. It's quite telling, sir. Quite telling.
Are you going to be quiet for a second while I answer it?
Carry on.
Yeah, go
I
on.
am now.
Whistling
I'll
past
be humiliated. Yeah.
question.
Okay, so you'd use a barometer, which measures the amount of force, the amount of newtons in a particular area. And you'd use that. So that would generally be how you measure gas pressure anyway.
What about atmospheric pressure?
Even atmospheric pressure.
So they're the same.
The instrument that you'd use would be the same, yes.
Yeah, because you're measuring gas pressure. What makes up the atmosphere? Does gases make up the atmosphere?
Yes.
Then gas pressure is atmospheric pressure.
Well, when you're talking about gas pressure inside a container, you're talking about...
No. Gas pressure and atmospheric pressure is the point. They're both the same.
I concede that, yes.
Okay. That's good. Yep.
Yes. So gas pressure and atmospheric pressure are the same. And the definition for gas pressure is it requires a container.
No, it doesn't.
Yeah. Well, you just contradicted yourself.
Yep. Because in the atmosphere, it doesn't require a container. Because
yes, it does, because it's gas pressure.
No.
Yes.
And if you want to talk about the containment, then gravity would be what you'd be.
Gravity doesn't have anything to do with it. I can be close to the Earth.
Yes, it does.
Even if I had, let's go down this lane because this is going to be fun. So even if I gave you all of the Newtonian force of gravity that you can muster, I'll give it all to you. And then on top of it, I'm going to give you Einstein's bendy spacetime, all of the bendy spacetime times 1,000. Those factors will not affect the entropy of gases one iota.
Yes, they do.
Oh, yes. You really? You doesn't make it right, and you have no... Two wrongs don't make a right. Okay, which type of gravity are we talking about, Professor Phil?
You've got no standing to say either, and
what type of gravity are we talking about here? You said gravity. What type?
Just gravity.
Just gravity. You know there's two types, correct?
Oh.
There's the universal law of gravitation, which was superseded in 1915 by the general theory of relativity.
Yeah, there's people have different views about why gravity happens.
Okay, so what's the current understanding of gravity today?
The effect that you notice when you drop something, that's gravity.
The effect that we notice, what type is that? Are we talking about the general theory of relativity?
Doesn't matter.
It doesn't matter. So how does gravity? I want the experiment showing when let's say we blow up. I'm not done yet. Phil.
You don't know
I'm
enough
not done yet, Phil.
For me
We're going to get to Einsteins here in a second. So let me ask you a question. Let's say you blow out your tire, right? And you go to Big Old Tire. I don't know if they have that down under, but you go to Big Old Tire. It's a commercial tire replacement here in the States. You go to Big Old Tire, but you notice you only got $5 in your pocket. So you holler at the technician. So you holler at the technician, and you don't have enough to pay for the tires. So you holler at the technician. You say, "Come on over here, man." You say, "Listen, I don't got enough cash right now. Can you just put the air pressure around the rim until I get home, and then I'll drive back with the cash for the tire?"
You thinking or something?
Yeah. Doesn't make any sense, does it?
I don't think that makes sense.
We're closest to the Earth. We're the closest to the Earth with our tire blowout, right? And the technician, he's right up against the Earth, man. He's right up against it. So the gravity, which you're talking about, should be the strongest. However, when he goes to put the air around the wheel without the tire, it doesn't stay there. Where does it go?
Why would it?
Well, that's my question to you. You're saying it's gravity. Wouldn't it expand to fill the volume?
What? You just said there was no tire.
Yeah, there's no tire, so it's not going to stay there.
So expand to what volume then?
Say it's going to fill the volume of the garage.
Space.
No, of the garage in this particular example.
Yeah.
What volume?
So, but that's where the gravity is the strongest. So you'd figure it would at least stay on the bottom of the wheel, but it doesn't.
It has energy. You know that.
Oh, it had. Well, you said gravity just a couple seconds ago.
No, but gas molecules and particles have energy.
Oh, I know that. That wasn't in contention.
Well, then do you see the problem?
Yeah, I see the problem. Yeah, everyone sees the problem. We're not going to talk about how you should be institutionalized until later. We're talking about gas molecules, right, that are supposed to form around this tire because of gravity, at least at the bottom. I can understand the top getting away, but the bottom is the closest to the Earth where gravity is the strongest, but they don't stay there.
But they have energy that can overcome that.
Oh, there you go. Thanks for proving my argument.
There it is.
Ding, ding, ding.
Welcome to Fire. Snaps in the back, Phil.
Wow. You just got teabagged.
And the bathroom's on the left. The DJ's on his way.
Not sure.
QE, thank you. QE got 2 concessions so far.
Hey, can I
that's
ask
great.
him a question? Phil,
I do like that. I like that.
Yeah, go ahead. Floor's yours.
All right, Phil. If I have a container and it has gas in it, right, on the Earth, and I pull the lid off, what happens?
Mm-hmm. The gas will go out.
Okay.
Well, it depends on how much gas.
Let's try again. I got a container on the Earth. It's got gas in it. If I pull the lid off,
How much?
What happens?
Would you have more gas than the outside of the container or less?
All right, man.
Or
the
equal?
gas fills the space, okay? Because you remove the lid, right?
Did you hear what I said?
Matter. Sorry, Witsit.
Is the pressure in?
It doesn't matter if you've got
the container the same as the pressure outside your container.
You mean the pressure would equalise, Phil? That's the point he's making. You're agreeing that what would happen is equilibrium would be reached. Yeah, any differential in pressure would instantly be equilibrated. Yeah, because there is no longer a physical barrier, a container, you may say. Yeah, to contain those 2 separate pressures.
In those local conditions,
as you beautifully described, it would equilibrate. Yes.
Okay, so yeah, of
Just
course,
the fact.
outside of it has less pressure, Phil. Stop trying to divert and drag me through the mud. I'm going to try again. Hey, Professor Phil, if you're a professor, you should be a little bit more coherent than this, okay? So if we got a container on the surface of the Earth and it's filled with gas, and then I remove the lid, what happens?
Mm-hmm. How much gas was in it?
Oh, my God.
Is it true or is it not true that gases without a container or a broken container will find their equilibrium?
Is that true or not?
Well, locally, yes, I agree. The gas would escape if there was more of it than the outside.
So we established that. Here's the follow-up. Okay, God, it's like pulling teeth, dude.
Are we in primary school, Phil? More of it, if there was more of it. Do you mean if the pressure was greater inside the container than outside? Phil, you're the only one that sounds like a retard here, mate, or like somebody who's being educated. Don't try and patronise anybody else to try and pretend in some way you're lowering your intellectual way of conversing. Yeah, it's quite clear here. It's quite clear here, Phil, that we're picking you up, son. So carry on.
No, you're not. You're acting like a bunch of idiots.
All right, here we go.
Don't worry about simple.
I got a simple, guys. It's simple, okay? It's just a follow-up. He's scared to hear it because I've handed this dude his ass 5 times already. So when we got the container on the surface of the Earth, it's got gas pressure in it, and I remove the lid, it will instantaneously feel the available space seeking equilibrium. So, Phil, if I have gas pressure on Earth with a container and I remove...
Stop.
I'm not done. So if I have gas pressure on the Earth and it's a container and I remove the lid, what would happen?
If you have a container on the Earth, let's say you've got a gas jar, for instance, that's got...
Phil, if the gas pressure on the Earth had a container and I removed the lid, what would happen?
If the gas pressure had a container, you're talking if the whole Earth was...
Are you an idiot?
If the whole Earth was contained...
Yes. If the gas pressure on... Professor Phil, this is a conditional preface, right? If the gas pressure on the Earth is contained, okay? So we have a container holding the gas pressure on Earth, and I removed the lid, what would happen?
Nothing.
Okay.
Nothing will happen to the gas?
Your rice will be raw and not cooked thoroughly. That's what will happen.
Shout out to Betty.
Hold on. Didn't you just answer me when I asked you, would the gas find its equilibrium? And you said yes. And now you're saying nothing would happen if you broke the container.
Yeah, I said that. Who am I speaking to?
Bambi, sorry.
Okay, Bambi. Nice to meet you.
You too.
Bambi, when you're talking about something small, like a small container that's got some gas in it, and then that's got more gas in it than the outside of that container, and you open the lid, of course the gas will escape.
Yeah, it'll fill the available space.
Until the... Well, it can't fill the available space. It'll go as far as its energy allows it to go. Let's say, for instance, I've got a litre. Container is a litre, and then I open up and let's say it's got enough pressure for equivalent to having 2 litres, let's say, of the outside gas, and I open it up. That gas that's in that 1 litre container will escape. It'll just escape to its surrounding area and bounce into other gas molecules that are in the area as well. It's not going to fill any container. It's just going to...
So
it's going to escape into the vacuum of space.
What container? What container?
So what's your container for us living next to a vacuum? What's your physical container?
There is no container, Bambi.
So you're having pressurized gas without a container?
It's not pressurized gas without a container. It's
You just said there's no container.
That's the opposite.
Do you want Bambi to finish her conversation or not?
No, she just decapitated you. We all heard it.
She's done nothing of the sort. My head is
you
still
just
on
contradicted yourself with back-to-back sentences, Phil.
You're a fool. My head is still on my shoulders.
Check again.
You agree with that or not?
I think it's on backwards.
Oh, look in the mirror.
I mean, the words you just said...
Did you have anything?
Yeah, I was just going to say the words you said just contradicted your claim.
No, Bambi, it didn't. Bambi, there's no container above the Earth.
Okay, so how do we have pressurized gas without a container?
Bambi, there's no container above the Earth.
So how do we have pressurized gas without a container? If there's no container, how do we have
Bambi,
our gas?
for the same reason that the gas at the bottom of a mountain doesn't rush to fill the top of a mountain.
Yeah, it moves omnidirectional, doesn't it?
Gravity, Andy. It's gravity.
What reason would that be, Phil?
I already explained it.
All right.
What's it?
Okay,
I'm gonna go have lunch.
I gotta. For one, you don't get the BS known as gravity. You just reify it. There's no physical empirical evidence of it at all. But we'll worry about that later. Do you agree that in your little paradigm brought to you by Jesuit priest that gravity is strongest, closest to center of mass?
Yes.
Okay, so if gravity is strongest, closest to center of mass, would you agree that the closest to center of mass that we have attainable would be the surface?
Of course.
Okay, so if I let gas out at the surface where gravity is the strongest because it's closest to center of mass and it instantaneously seeks equilibrium with omnidirectional dispersal instantly, right? Then how could it be that it doesn't do that much further away from the center of mass where it's weaker?
Did you not understand this business about the energy as well that comes into it?
Hey, man, I'm going to try and ask you again, okay? If gravity is the strongest, closest to center of mass, and then the closest to center of mass that's attainable is actually on the surface, and then when we let gas out at the surface, it instantaneously seeks equilibrium with omnidirectional dispersal, how could that ever be prohibited from happening much further up above the surface, further away from the center of mass where it's much weaker?
There's always a fight between gravity and energy.
Do you think that just answered my question, Phil?
Yes, I think it did.
Okay, and you teach other people things?
If you have sufficient intellect, that should pretty much solidify it for you.
Actually, the velocity of the gas molecules is much higher up higher in the air, right?
No,
so you're saying that the gas particles move slower up higher in the atmosphere?
100%.
Okay, so they move
with the Earth.
They move slower at the up higher, so then gravity's able to contain it. Is that your claim?
You got it in one.
Okay, then how do tons and tons of gas ever escape then if they're not going any faster?
Because they are not every gas molecule doesn't have escape velocity.
So some of the gas does, some of the gas doesn't.
Gravity's we already been over. We already been over this, man.
Fair enough.
We've already been.
Yeah, that's when Adam teabagged him.
Oh, okay.
No, but
I'm curious to what Professor Phil. What's the necessary antecedent for gas pressure?
We already been over this too.
We did that too.
Did you? Did he answer that?
I'm not interested in listening to what.
He said definitely not a container, and then QE read him about 30 citations that said it is a container.
Out of Nathan Oakley's Bible. I'm not interested.
Do you remember that?
Nathan Oakley's, hold on. Adam, fucking hell, he's not even here. What? Nathan Oakley's Bible? No, these are citations for gas pressure and it being a container being the necessary antecedent. Necessary antecedent for gas pressure, like you said, is not just gas. You fucking imbecile.
This
all came
law, Phil.
Yeah, this all came from me asking him a question about the measurement of Earth curvature, and he didn't know about the anybody that did it in ancient times. So he referred to the Himawari 8, taking an image of the Earth, and then that's where we got into how could that be possible if the Earth is contained and it's a closed system and not an open system like the one you're describing. So he started to describe why he thinks it's an open system as to gravity being the container, and some molecules leave and some stay, and then that's why he's still thinking that in his paradigm.
That's another subject. That's maybe a new subject.
That's a good summation.
That's maybe a new subject, Miggy. Would you ask him? This is going to be a lot of fun. Would you ask him to tell you the difference between open, closed, and isolated systems? Get your popcorn, folks.
Why wouldn't I not know that?
Oh, because I listened to you talk about open, closed systems. That's why I'm asking Miggy. Let's see if you change your story.
When did you listen to me even mention it?
A number of times on Jose GG Retard Show.
Don't think so.
So we would,
to be fair, Phil,
Professor Phil, we would say that the Earth is a closed system. Is that what you would claim as well?
No.
Or is it okay, so it's not a closed system. What would you say it is?
An open system.
So have them define it, Miggy.
Yep.
So matter leaves the Earth and returns to the Earth, and so does energy.
That's an open system?
Yeah.
What's a closed system?
This is where matter can't leave the Earth, can't enter the Earth, but energy can.
Isolated.
This is where nothing can leave or enter.
Outstanding. You change your story. At least you can learn.
I should think so. They gave me a job as a professor. I think.
Well, like I said, I have you cited in the toe tag that I did on you, where you said that was incorrect. You said it's not qualitative; it's quantitative. That is, if there's a little bit getting out, then it still can be a closed system.
No, that's not what I mean.
John.
Yes.
I think Professor Phil has correctly described it. He can be held to it, and it's a good point to move forward from for those clear definitions.
Okay,
they're going to be useful as we move forward. So let's carry on. I think that's a great set of defined, comprehensible definitions that he's provided.
I agree. Adam. So is the Earth a closed or open system?
I already told you it's open.
So it's an open system with gas pressure.
Yeah.
But gas pressure, as we just went over about 20 minutes ago, has the necessary antecedent with a container in it.
No.
Oh, no.
Nuh-uh.
Yeah, that would be matter. Matter and energy can escape, right? With the open system, Professor Phil.
The atmosphere, no.
Right. If it's an open system, matter and energy can escape.
Yes, and it does.
Right. So why does it all escape?
So how are we still breathing?
Because I told you, gravity. Well,
there's that sounds like that sounds like you're amending. You're making like a kind of like a side note to what you're just. How is it an open system but with selective things that are held back? Why? You know what I mean? Like.
Automatically makes, and matter leaves the Earth, and so does energy, and that automatically makes an open system. It's just on that alone.
Right. So why is it all leaving then? Because if you're saying that
I told you why it doesn't leave.
Right, I know, but so gravity is now making it a closed system by the way you're defining it. No,
because gravity can't do it all.
You don't even understand your own religion. Gravity acts as the container in the atmosphere in your own paradigm, dude.
Gravity doesn't stop us from putting a rocket into space. That's matter.
Oh my God! Hey, Professor Phil, how many vectors does gravity have?
Down. That's it. Towards the center of the Earth.
A singular vector of down relative to the center of mass.
Yeah, pretty much.
No, there's There's no pretty much. Okay, so gravity has a singular vector of down relative to the center of mass, right?
Gravity applies to all objects.
Does gravity have a singular vector of down relative to the center of mass, yes or no?
The center of Earth. You need to qualify.
Oh, the center of mass, actually. So you don't understand your own religion again.
Yes, the mass of Earth. You need to qualify that.
Well, that's what we're talking about is the Earth, Professor Clown. So how many vectors does gas pressure have? Hey. How many vectors does gas have?
Hey, listen, if you don't retract that last statement, I will not talk to you again.
How many vectors does gas have? Okay, I'll retract the statement that you're a professor. How many vectors does gas have?
Otherwise, I don't talk to you anymore.
Okay, I won't call you Professor Clown anymore because you're a gammon and you're filling. So gravity has a singular vector of down relative to the center. Dude, you're trying to run away because you can't answer the question. And you're looking for an out right now. I retract all the statements. I'm so sorry I hurt your feelings. I didn't mean to be disrespectful. So, does gravity have a singular vector of down relative to the center of mass, yes or no?
The center of mass of Earth.
Yes. Is the answer yes?
Of Earth, yes.
Okay. Does gravity have a singular vector of down relative to the center of mass of Earth?
Yes.
Okay. How many vectors does gas have?
Infinite.
Oh, so it has infinite vectors. So
Depends
if
on
gravity has a singular vector. What?
Yes.
Okay, gravity has a singular vector of down relative to the center of mass of Earth, but gas has infinite vectors. How could a singular vector be sufficient containment of infinite vectors?
Okay, so each particular molecule or particle has mass, and mass is in the influence of the gravitational field, which Earth has, will head towards the center of Earth.
Oh, Phil,
Really?
so are you saying?
What about the gas molecules?
Phil, you're saying
that's the default.
That gas behavior is not as described. No longer is gas behavior random and in all direction based on the angle of last collision. He's saying that additionally to that is subject to an additional downward 9.8 acceleration. Is that your claim, Phil?
Correct, exactly. You got it.
Can you demonstrate that, please?
Yeah. For one, you can't demonstrate it. But I got a question.
Why can't I
what about
demonstrate
the
it?
gas molecule that
Why
goes
did you
straight
say
up,
that?
Phil?
Stop. Why did you say I can't demonstrate it?
You can't demonstrate.
Show us gas coming back.
Can you? I said, can
Offer
you
a physical
demonstrate
demonstration of gas pressure without a container.
Of course.
Hey, that's my question.
Waits for it.
Motherfucker.
Easy.
Here comes the reification of the atmosphere.
It always comes back down to it.
Is that why balloons go down at Christmas? Because all the gas settles at the bottom.
Let's establish some apparatus. Would you?
Oh, you're going to make some bullshit
container
plus or minus 0.001 grams.
Oh my God!
Is that hard to imagine?
Dude, you already contradicted yourself with the gravity vector, single vector, sir.
Well, you just.
I'm sorry. Is this him demonstrating?
Yeah.
Gas pressure without a container.
If gas molecules move rapidly in all vectors, as these citations state, and you already stated, forgive me. If gas molecules move in all vectors and gravity has only one vector, then how does gravity affect all vectors when it has only one? It's a contradiction in terms.
Are you going to let me talk now?
Talk. You can't talk your way out of this. This is a law of non-contradiction violation.
Let's just go for it.
Things can't have all directions and only one direction at the same time.
Why don't we'll just see if I can't finish?
He's going for it, man.
All right, let him go for it.
Just do it, Nike. Just do it.
I'm actually talking to Bambi, okay, on this occasion. So Bambi,
why?
So Bambi,
you're talking to Bambi? You sexist pig.
Is it okay if I could just talk?
I just want to know why you're only
sitting on the edge of our
Bambi.
seat, waiting for your demonstration that you keep running away from.
We're all Bambi.
So what's your demonstration for gas pressure without a container?
Right. See if you can just keep them quiet, by the way. All right.
Every one of us is doe-eyed, waiting for you to make a salient point.
There we go again.
Right. Let him go. Let him say his thing.
Okay.
Go on, Phil.
So Bambi, if you have a set of scales, let's say plus or minus 0.001 grams, you just put it flat on the floor or a table, wherever you are, and then you get a beaker of SF6, sulfur hexafluoride gas.
I'm just going to grab that from the store down the street real quick. Hold up.
It's a man-made gas, isn't it?
Yes, that's a man-made gas. Why don't you use natural gas? I'm sorry. That's man-made gas. That's one of the top 10 greenhouse gases. Why aren't you using like oxygen, nitrogen, helium, hydrogen? Those ones.
But isn't it also contained within a beaker? How are you showing gas containment without take away the beaker? Is what I want from you.
Yeah.
Why are we going to set up? Why are we going to set up an artificial disequilibrium before we start? Why are we going to preload a container, admittedly open at the top? Why are we going to preload that and pretend that it's atmosphere? Why don't we just discuss it as it is? So we create a new medium which is more dense than the thing we're about to put into it. So let's continue with that understanding with this explanation. We're about to put something
are we okay?
Quite as dense as the medium we're about to put it into.
Are we okay for you to just shut up until I finish?
It must hurt, mustn't it? It must hurt.
All right, I'm curious to where he's going to lead this.
Yeah, it sounds like, sorry.
Because I'll wait for you to take away the container.
Okay.
Sounds like Bambi has to hold his hand now.
All right, so all you need to do is if you can zero the scales, Bambi, you know what that means, right?
Yeah.
Okay. And then you can take your SF6 and just pour it on top of the scales.
Okay.
And it will register a force. It will register.
Yeah, will the numbers stay there? Will it just sort of contain, or will it find its equilibrium?
Eventually, the gas will just.
It'll disperse. It'll find its equilibrium, so it's contained.
Just like water would. Yeah.
So it's contained.
So it did create the pressure, right?
Well, now, does it stay there?
Ding, ding, ding.
Does it stay there, or does it eventually disperse omnidirectionally, seeking equilibrium?
He's doing magic again.
Constant pressure.
Magic.
Constant pressure.
Andy, why did it register anything at all?
Does it change the speed at which you pour it out at? The angle that you tilt your wrist, does it change? If you tip it faster, will it register more or less? Or will it just register the same?
Just like you would if you did water, Bambi. Exactly the same.
Professor Dappler, right? Is the collision, is the change on your scales, is the change on your scales relative to the number of molecules of the gas hitting it at a particular point, even though it's slightly heavier than the medium you're pouring it in? Or is the change on the scales relative to the total amount of molecules, and is it representative of the total amount of molecules, or is it representative of the total amount of molecules hitting the pan balance?
That's a good question.
Well, no, sarcastic, so clearly you don't understand. That's shocking. It's not a good question. It's bleeding obvious, mate. It's bloody obvious to anyone with a science degree. Are you sure you're a professor? Seriously, or are you a charlatan? Because that is abhorrent that anybody that professes to be an academic and a teacher of people would misrepresent people like that. You should be ashamed.
What did I represent?
You should be ashamed of yourself.
What did I misrepresent?
Absolutely shocking.
What did I misrepresent?
You tell me, Daphne. Go on, make your point.
Well, yeah, the bit that I'm curious about is just pouring it out.
Andy, what do you think caused the needle?
Snake oil salesman, mate.
Yeah, does the number? Yeah, does the number stay the same, or does it find its equilibrium?
Well,
is the number consistent?
Yeah, eventually, all of the gas would move away from the plate. Or most of it will.
Yeah, and fill the available space.
What available space?
So you're not demonstrating gas pressure within a container.
Yes. So do you think that any of that gas would, when you say fill the available space, do you think any of that FS6 would ever make it to the firmament?
Firmament. It'll get up high because it's one of the. Hold on. It'll get up pretty high because it's one of the top 10 greenhouse gases. Let me ask you a question, sir. What did you bring the sulfur hexafluoride into the experiment with?
Why not?
What did you bring it in with?
Because the reason I brought it in is because it's so dense.
What did you bring it in with?
Imbecile.
Adam losing.
Did you just ask him to follow you, Phil? Yeah,
is it
did you push it in and squeeze it into the container before you started, or what? How did you get it into the container? Were you squishing it in, or did you release it from another container that was probably smaller?
Just had a bottle of it and just poured it in. Just like I poured
was the bottle
a bottle?
I'm failing to see where the demonstration for gas pressure without a container is. I'm failing to see it. I'm sorry.
I'll show you what he's done. So this is where the magic is. This is where the magic is. Because it's dense, he's got a surface he's poured the gas onto. The gas has pressed down, he's registered a force.
Mm-hmm.
Perfect.
That's it. So gas pressure.
He got
it's
it
not
in one.
Gravity. It's just
gravity. What do you think
You're just aren't you just measuring weight?
No, it's not gravity. It's the relationship between sulfur hexafluoride and atmospheric gas, because it's denser than the atmosphere around it.
Because gravity causes that to happen.
So you can't just reify your claims, right? You have to actually specify with empirical evidence. You don't just reify and then beg the question. You know that, right?
No, Bambi addressed this point at the beginning of Phil's waffle here, yeah? Well, let me do the point.
Professor Phil.
He said, if you pour it faster, will it give more of an effect on the scale? Yeah, and that's the point. That what Phil's trying to do is pretend that force. He's now trying to equate falling force of something which is heavier than the medium you pour it into, the impact it has on the balance. Yeah, and as it was said at the beginning, if you pour that thing more or tilt it at a greater angle, will that change the reading on the scale? Phil?
It'll just make the reading go faster, yes.
So is the reading, what's the reading relevant to? Number of collision impacts through gas behavior as it falls through a medium. As it falls through a medium that's less dense than it is. Yeah, that's the best it is, isn't it? It's not certainly not a measure of weight or mass, is it? It's an impact level, isn't it? And if anything, the only thing it could show you would be rate of fall as a correlation to reading on the scale, and you might be able to show a differential with different gases there. But that's not showing you anything other than gas behavior, isn't it?
It would be exactly the same as if
slightly less dense medium than the previously pre-selected gas. If, for example, Phil, you took the same jar of helium and poured that, what effect would that have on your scales?
The helium would rise. It probably.
So what effect would that have on your scales, Phil?
It wouldn't.
What other gases would have an effect?
So we're not demonstrating mass, though.
Carbon dioxide.
Hey Phil, I have a question.
Any gas that's more than 29 grams per mole would have an effect.
Can I ask you a question? If I have like a closed container of sulfur hexafluoride gas, like I just have like a container of oxygen, just like you have another container of gas. If I have a container of sulfur hexafluoride, is there any downward effect on the gas in the container, or does it move omnidirectionally in the container? Because I feel like this is the point that also happens with the other gas, like helium, is that as soon as you expose it to the, like whatever equilibrium it's in, that would be the atmosphere, gas pressure, that means relative density is affecting your, like what direction it moves in, right? Which is why the helium has no effect. So if it was in the container, would there be any down vector at all? I mean, there would be a random one from the collisions, but without the relative density, would it fall to the bottom because it's so dense?
I get your question. That would depend.
I'm just trying to understand this, right?
I got your question. You want the answer?
Well, obviously, Phil.
Oh God.
Sorry, on you go.
Okay. So that would depend entirely on whether the SF6 in the bottle that you're talking about was under pressure or not. If it was under pressure, then the amount of gas that's over and above the pressure from on the outside would escape, and the rest of it would stay where it is. So
I specifically said a closed container. Just like if I have an oxygen tank that I can turn open and close. If it doesn't open and close, there's nothing to escape, right? There's nothing to escape.
If you open the container and it was not under pressure,
I didn't say. No, wait, hold on. I know you're trying to answer my question, but my question wasn't if I open the container. My question was what happens in a closed container of sulfur hexafluoride? What happens to the molecules inside it? Not if
I open it, what happens if it's closed?
Is it completely full right to the top? Is there any space in it at all?
I don't know. I'm asking you if I have a container, like if it's a tank of like I have a tank of helium. If I fill that with sulfur hexafluoride and I leave it upwards, what happens? Does it all collect at the bottom or something?
If that tank doesn't have any pressure and there's some space inside it, then
it's a container, right? There's space inside it.
Okay, so at the
Phil,
surface,
he puts two molecules in, right? Let's keep it simple for you, daft lad. He puts two molecules in the container of sulfur hexafluoride, right? What happens to them? Do eventually they settle and, due to gravitational entropy, settle at the bottom of the container after X amount of time?
If there wasn't any heat, yes, they would settle.
No, everything else is contained, Phil. What happens?
But there's always heat, isn't there?
We cool it down. The temperature stays the same. You're claiming that there is a force that is having a negative effect on the kinetic energy of these gas molecules. This force, you proclaim, is gravity. Because if we put two molecules in, A, will they decay at the same rate, Phil? Or B, will they not decay at all? And or C, do they decay at different rates? And if so, why?
As long as they're losing energy, they would eventually succumb to gravity, and they would fall.
They're kept at the same temperature, so they're bunging around the container. Yeah, PV equals NRT. The temperature's the same. Yeah, just the two of them. And you're saying there's an additional entropic force applied to them in the form of gravity. What happens to them?
There's always the gravity is always one of the forces that's
it's stopping them continuing in their gas behavior, isn't it? Because at the point where they reach the Kármán line, they turn back. So you put those two molecules in there. How does gravity affect them? Describe it, because that's got to be a basic. It's a basic.
Gravity always affects them, but
describe it.
If they have enough energy, they will keep moving. I'll keep going.
Keep them there forever. How long okay, this must be a basic physics question based on that. How long do I have to keep one gas molecule there moving at 5,000 kilometers per hour? How long do I have to keep it there within a container for the negative constant downward force to apply so that the gas molecule loses all of its kinetic energy? That's a basic of physics. Your model, surely. It's fundamental.
So every time the gas molecule hits a wall,
not going to answer, are you?
If the wall of that container, it will lose some of its energy.
The wall's the same temperature.
No, it won't.
The wall's the same temperature, mate. No, the wall's the same temperature, right? So we're fine.
Do you understand that when in a collision that some of the energy is lost in the...
They're elastic collisions, you doofus! We went over this an hour ago!
There's no such thing as perfect elastic collision.
Yes, there is! Oh my God, you'd fail. You'd fail junior high level physics.
Phil, are you saying then?
There's no such thing as perfect elastic conditions?
Phil, that's absolutely fine.
Yeah.
Phil, right, but that means that your reason for the entropic loss of kinetic energy is due to non-elastic elastic collision, which is fine. But it doesn't take us away from the reason that you're saying that these molecules lose their kinetic energy. So let's go back to that. Okay, so how does gravity affect the kinetic energy of a gas molecule and gas behavior? How does this apply? I'm assuming there's some kind of downward vector.
Another one of those forces that become the net force that's acting on a particular particle.
Okay, so after an elastic collision, so two molecules hit each other and away they go. And they've both got their energy and their angle. And they go. And we plot its path off to infinitum. How, when within gas law do we plot a downward additional force applied to that gas particle's trajectory? Can you show me where that's ever done in physics or chemistry?
Well, not that particular particle, but
no, it's not, Phil, is it? It's not taken.
Yes, it is.
It's not part of because it's not because fundamentally that's not a part of gas behavior, is it?
Yes,
in fact, to try and pretend it is would be to have to rewrite all of those laws, isn't it, Phil? Isn't it?
You don't know what you're talking about.
No, it's not rubbish. Carry on then. You rewrite those laws. I'll leave it to you.
You don't know what you're talking about.
Hey, Professor Phil, let's do this. I'm going to recap what we've covered, and you tell me what I've done wrong, and you voice some contention, okay? So we asked you for a physical demonstration, a practical demonstration of gas pressure void of containment without a container. You then invoked sulfur hexafluoride, a synthetic. I'm still talking, bud. You then invoked sulfur hexafluoride, a synthetic gas, and then you said, oh, well, look, it's going to actually be registered on the scale. We asked you what's going to happen if you leave it there. Well, eventually it's going to gradually dissipate into the surrounding area and fill the available space with omnidirectional dispersal, and you had to actually bring the synthetic gas in a container itself. So you invoked two different containers, and you didn't actually even address the primary thing you're supposed to be addressing, which is the fact that it's going to fill the available space with omnidirectional dispersal over time, because that's what gas does, seeking equilibrium. So would you like to try again and try and give us an actual practical demonstration of gas pressure without a container?
No, the one I gave you was sufficient.
I just explained 4 different ways that it wasn't.
No, you didn't.
Okay, it's just a synthetic gas. It actually doesn't just stay there. It still fills the available space, seeking equilibrium. So that doesn't actually answer your question. And to even bring the gas there, you have to put it in a container. So if it doesn't just stay there, then that isn't going to actually address our issue, because it eventually still disperses omnidirectionally, filling the available space, seeking equilibrium, right?
What's that, Phil?
Nothing you said there made any sense.
Wait, yeah, you did. So you did. So it sounded like you just hand waved what Witsa just said, Phil.
You bet.
Why?
You bet.
Why did you address it? Because he said something
did you hear what he said?
Yeah, he said something very damning to what your argument was, and I'd like to. Why was it? Why don't you have? I want to hear your response. Like, that's what I'm here for. I'm trying to listen to what you got to say. Like, you need to respond to what he said. That this is important.
But Phil, can you repeat what Witsa said so we know you understood it?
When I told you about SF6, I told you it would behave just like water would.
Yeah, but did you hear what he said?
Yeah, what did I say?
That's what I'm saying. Can you repeat what he was saying to you so we know you understood it?
You started off saying it was a synthetic gas, as if that makes a difference.
And what else
did he say? Well, it does, because it's not naturally occurring, but move on. What was the primary point?
So what?
What was the primary point, Phil?
Okay, the next thing you said was that I had to bring it there in a container.
Yes.
Okay.
Which of course I would.
Could you bring it there without the container?
No.
Okay, so that doesn't demonstrate gas without a container. So then what was the next point?
Okay, so I brought it. I bring it to the scene in a beaker. You know what a beaker is?
That's a container. So what was the next point?
Without a lid.
What was the next point? Yes. And if I just leave the beaker there without the lid, and over the course of time, it's going to eventually dissipate, seeking equilibrium and omnidirectional dispersal. No. So this is not sufficient invoking of a practical demonstration. Do you understand?
No.
Okay, so okay, stop, Phil. Why did you say no to what he just said?
Because some of the SF6 would remain in the beaker.
What time frame are you giving this? Infinity, or like what are we looking at here? What's the time frame? You're saying some would remain in the beaker. What are you saying? Like in an hour, a day? Like what's your time frame here?
What's it matter?
Well, it's important. If it's 5 minutes later, if it's 5 minutes after you used it, there's still going to be some in there. So what you're saying would be correct in a short time frame, a minute, 2 minutes. Like if you left it over like a week, you think it would still all be there? Like even if the
temperature was say 0, yes.
No, you're not
like your IQ. Wow. No,
we're not talking about the temperature. You're changing the variables here, Phil.
No,
you just changed the. You did. When did we introduce the temperature was at 0?
When did you introduce the temperature at anything?
When did we?
You said that it was at zero right now.
Explanation of no container.
I prefer.
Phil, why don't you show us?
Right?
Why don't you show us this
Right.
demonstration that you've done?
So,
Why don't you show us and you tell us all the variables of it so we know what we're talking about? Because the temperature wasn't discussed, so just show us everything.
Well, temperature's
Show us what you've done.
Bambi,
Yeah, so that's what I'm saying. Can you provide what you've done and the observation you've made of gas pressure without a container so we can see it?
Phil, everyone here knows that temperature and pressure are intrinsic, okay? Do you agree?
Of course.
Okay, so the point here is we've asked you to invoke a practical demonstration of gas pressure without a container. You've invoked a synthetic gas, sulfur hexafluoride, that you bring in a container and then you put on a scale. And then actually what it reads is dependent upon the acceleration that you have introduced, right? The force and acceleration you introduce, that's what's it's going to read. And then if you leave it there on the plate, over the course of time, it will seek equilibrium with omnidirectional dispersal.
You don't agree with that, Phil?
Over a period of time, if the temperature was right, of course it would, yeah.
Okay.
So this is
all right.
not sufficient.
Talk about something that doesn't have a container.
Right.
So I guess if the temperature was cold enough, it would stay in the beaker.
All right. Well, Phil, here's the thing. I'm still trying to, real quick, Adam. What I'm still trying to do is get to the point where we're going to measure some curvature, because we can't do that if your satellite is in a medium that can't exist. So right now it's saying. Well, no. I'm saying. I know you're making a declaration, Phil. I know you're making a declaration right now. But what we've been trying to do right now is get you to at least understand that if you have gas pressure, you need a container. But you can't demonstrate that you can't have a container. Like this whole time, I want to say I've been here for like an hour and 30 minutes. Professor Phil, and you haven't demonstrated how you can have gas pressure without a container. It seems like every method that you've introduced, it fails on every level. And I'm waiting for the
just your opinion of it.
I'm waiting for the demonstration so that we can move forward and provide the. I'm waiting for the demonstration so we can move forward to provide the measurement of Earth curvature with your Himawari 8 in the medium that you say it's in. But if you cannot do that, then that Himawari 8 image that you showed me, I have to throw it away because you're not demonstrating gas pressure without a container.
So, Professor Phil, let's ask him this. Can you provide any evidence of the convexity of terra firma without invoking something in the very medium that's in contention?
Watch the ships go over the horizon.
Okay.
Okay, so
right.
So if we see the ship go over the horizon,
every time you go higher, you see further.
I got a gift for that. Phil, tell me if this is.
All the other planets are all spherical.
Phil, tell me if this is not what you're talking about right here. Go to Livestream Voice 6. Is this what you're talking about, Phil? Look at that gift that I put in there. Please make that observation of what I'm showing you. Livestream Voice Text.
Looking, I didn't realize there were so many messages.
You've been. Go to the very last one. It's just a gift that shows what you're talking about.
I'm trying to get that.
Okay,
this has been really busy.
I've never seen it.
Yeah, I've never seen you keep mentioning containers.
Incredibly busy.
People keep pointing out how many times you say container.
So this is. I'm sorry, guys, but this is what Witsit was saying right now with what you just told him. So I'm just wondering, is this what you're talking about? Once you get there,
I'm just trying to get to the bottom.
All right.
Well, Boomer, if you click the arrow, it goes all the way to the
there's the ship. Yeah. Well, yeah, okay, yeah, that's certainly what I'm talking about, Miggy.
All right, what's it?
Okay, so my question for you is, if I go back the next day, will this disappear at the same distance?
It might vary slightly depending on your atmospheric conditions.
No,
wait. No.
Actually,
the size of Earth changes from day to day.
Yeah. That's what I was going to say. So you're saying slightly, meaning that the position of where we would see the horizon would change?
Yeah. So what will happen is it's possible to have looming. On a.
So now we already went over.
All right. So we're saying that where we see the horizon change,
but the effect would still be the same.
All right, but we're talking about physical Earth curvature.
Yeah,
right?
The ship will still disappear the same way.
But not at the same place, will it?
How do you know if it's looming or actual curvature? How do you know if it's looming?
That's simple with them, right? Like, if you're claiming that this is physical obstruction of the convexity of terra firma or Earth curve, then that means it would have a consistent location dependent upon your metric claim of the radius, okay? But if I go back the next day, no,
because there's atmospheric refraction.
Right.
The horizon's dependent upon the atmospheric refraction, right?
Of course.
So then it's not a physical location then, right?
Well, it is. It's just where you see it.
So
Whoa.
It is. It's just where you see it.
Yeah. That's physical.
That's right.
How can you measure that, Phil?
Genius said that.
But how can you measure that? It's something that moves all the time. How are you going to measure that?
Well, you can look at you can measure the atmospheric conditions.
Okay, so that means it requires a presupposition of a physical location, and then you take an approximation and just assume and reify the very thing that's in question. So calm down there, Mr. Professor. Professor, is there a difference in an apparent and actual location?
Sorry?
Is there a difference in an apparent and an actual location?
Well, apparent just means where you apparently think it is.
Apparently,
the actual location is where it actually is.
Okay, so is what we're seeing the apparent or actual?
You're still looking at the same object.
Hey, we're talking about the horizon. Is it apparent or actual?
Okay, so where you see the horizon is in this particular instant where it's pretty clear. Then the horizon would be just slightly different to where it actually is.
Okay, so it's apparent then, right?
That would be apparent.
Slightly. So are you saying the horizon? Like Professor Phil, you're saying the horizon's different from the Earth curvature?
No. So what's different is not the horizon. It's the horizon is still the horizon. It's just in a different place.
What?
Welcome to Flat Earth. Snacks are in the back, bathrooms on the left, DJ's on the way.
I don't think so. This image alone, this GIF alone that you're watching.
You didn't listen to me.
Is
I said, welcome to Flat Earth.
You need that the Earth is a
welcome
sphere.
to Flat Earth, sir. And you invoked refraction. Did you know that you invoked terrestrial refraction? What do you need to calculate for terrestrial refraction, sir?
Oh, I know.
Temperature gradient.
Nope.
Yes, it does. Okay.
What else do you need?
Well, you need to have a different. You need to have a temperature gradient, or
Professor Phil. How often do you?
No, hold on a second. No, Professor
in
Phil.
Geometry.
No,
in geometry, you don't use atmospheric refraction.
No. Hold on. What do you need to measure terrestrial refraction?
Well, you need to know where the exact distance is to the thing that you're looking at, and then you can using your optics, you can find out what your apparent distance is, and from that you can calculate.
Are you going to use in the formula? That's what he's asking you.
Calculate the atmospheric conditions.
Radius.
Begins with R.
What about it? You talking about the radius?
Used to calculate your terrestrial refraction. What constant value within your formula for terrestrial refraction do you need?
Well, if you're talking about the Earth, you're talking about the radius of the
Earth.
Where'd you get that?
Isn't that what you're trying to prove?
Many ways to get that.
Many ways, brother. Many ways.
Yeah.
Well, the best way, obviously, is the Cartosat 3 or the Himawari 8.
No, are you saying that we can? You can't use
from
space.
Wait, you can't use your satellites, Phil. Remember, you can't use your satellites. You can't use your satellites because you said that we haven't gotten to proving that medium is actually there.
Mickey, I don't.
They proved the radius before they got to space. To prove the radius,
I do. I care very much because this is something that you're actually supposed to tell somebody is actually there. I'm not going to tell somebody something's there when I don't even know it's there because I can't provide evidence to have gas pressure without a container, Phil.
So, Miggy, let me explain to you how this works over here. See this image that you put up? It's actually very, very good. I love it.
I'll put it again.
We love it too because it proves that the horizon is nothing more than an apparent location that constantly fluctuates hour to hour, day to day based on atmospheric conditions. But I'm not done talking. But yeah, you claim that there's a physical obstruction. Shut up, dude. You claim there's a physical obstruction that's consistent based on the convexity rate that is necessitated by the radius. So whenever it fluctuates, as soon as it moves, it disproves the notion that it's a physical location. So once again, welcome to Flat Earth.
So, Miggy, this particular image that you've put up here is really, really good. Okay, and let me explain why. Because you don't have to do a lot to work out that Earth is a sphere just looking at this image. So one of the things you can do, Miggy, is over.
Can you get the radius from this picture? Can this picture provide a radius? We're talking about the radius.
Yeah, we're talking about the radius, sir.
If you just
where was the radius
value from this picture?
Who and by what method was the radius value established?
I'm about to tell you how to do that.
No. Okay. Who and when was the radius value established for the Earth?
Gosh, can you just be quiet?
No, you need to answer this question.
So you gotta let him beg the question first.
No, we're not letting them do that.
You have to understand that we're trying to establish the verification process of the radius. You can't even go to your little natural law-defying medium without the radius because you can't even attain gravitational orbit or escape velocity without the R value. So you're reifying and begging the question. The very thing in contention is the R value. How do you establish the radius, Phil?
So Miggy, that gift that you got is brilliant.
I'm going to ignore everything, just all of the questions. I'm going to ignore.
Let me just explain.
No, we don't want to hear it anymore, unless you're going to tell us where the radius.
Why can't you debate the college dropout, Phil? I'm confused.
Are you actually the queen?
You're going to use your explanation to find radius by something in the space that you needed the radius to know before they went to space, right? How did NASA know what the radius was before they launched friggin' satellites?
I'm going to explain to Mickey how this image that Mickey's put up.
Mickey knows about that. He's the one who posted it. You're the only one here who doesn't understand.
I know, but you may not realize some of the stuff.
You're self-projecting.
I'd like to explain it to him.
You're spiraling.
I'd love to know how
it's a gamma spiral.
You can't talk to the college dropout.
I know that the rest of you don't want me to go there, but
no, we want you to answer the question.
Mickey, I know you care about what you.
Mickey doesn't care. I asked him; he could care less.
Yeah. So I'm going to explain to you and the audience.
Well, you're not going to.
This is a brilliant GIF. Okay, and the reason is.
Can you get the radius value from that GIF? It's brilliant and all, and I get it. But can you get the radius value? You can get the radius value from that GIF.
Yes.
How?
I would love to see. Oh, please enlighten us.
Well, exactly what I was trying to do this whole time.
All right.
The radius. You're going to prove the radius right now. Everyone, quiet. He's about to tell us about the radius from this GIF. Oh, yeah. Go.
Right. Okay, so one of the things you can do is you can plot the distance that the ship moves against the height that this ship moves away. Okay, so as the distance that the ship moves against the height that it moves away. So all we need to do is work out. All we need to do is figure out is how fast that ship is moving, because that'll tell us how far away it is at each given point when we're looking at the distance above the horizon.
Yeah, but it changes hour to hour, though.
If we plot the distance above the horizon against the distance that the ship moves away, we can then plot that against so that we get a curve.
But it changes the next hour, though.
Oh, the ship is a constant velocity across that.
No. But where it disappears, it changes, though.
The ship's moving at a constant velocity across the water.
The horizon changes.
Yeah. I'm talking about on the same day, on this image that you're looking at.
It changes in the same day.
The horizon's not going to change in the few minutes that this ship's going away.
No, it's a few minutes.
All right.
Actually, yes, it could. It absolutely could change in a few minutes.
Yep.
It will be insignificant even if it could.
Oh, so that's a subjective interpretation of what's significant.
I'm trying. None of you actually care.
Phil, you started this.
What if a fog bank
don't actually care, do you?
What
Phil,
if
no, you started saying that optics couldn't define location.
I told you I'm going to explain to you how to do the radius.
Again, to back it up.
I told you how I'm going to get you to. I'm going to explain how you can use this image
have to reposition.
to work out the radius.
The only way you can reposition it is refraction and R. How do you?
No, I'm not talking about that. That's not
From
what
this
I'm
image,
talking about.
how do you know how far away the boat is in this image? By looking at this image, how can you tell how far away the boat is? Are you kidding?
All right. So this is
by looking at an image.
So this is what we have to listen carefully.
Oh God!
Right. So
if only there was like a demarcation point in the ocean, like an oil rig or something, where you could get an accurate reading.
No, you can, because they are sea lanes. Okay. Right, they're specific.
And this guy, man, this fucking guy.
On a ship this size, don't just go anywhere. All right, they follow specific sea lanes.
But and from this picture, how did you determine the distance? Just from this picture, how did you determine the distance?
You can go to a normal nautical map and work out where the sea lanes are. You'll be able to work out how far.
No. From this picture, you said from a picture you can determine the radius.
Yeah,
you said from this picture.
I'll use this picture and where it is to
and
go
the
and
topographical map and a calculator and a whole bunch of other stuff.
You see, because I actually do care what I believe in is true, so I would go the extra mile to do it. Okay, so
but you just said no, but you just said you can do it with this picture.
Yes, this
that doesn't make a lot of sense.
So
how did you? So we're in this picture. Where did you determine the distance?
Shut up! I'll explain it.
No, you won't.
So
the distance.
So in this picture here, what you've got to do is over time, so you've got to take the time into account. Over time, you've got to measure, you've got to plot the height of the remainder of the ship above the horizon, plot that against the distance that the ship is away. And when you do that, two things will be possible.
Put that formula in here.
Update. Everybody here.
No, hold on. I want that formula in here right now.
Two things are possible if you do that.
Now, we want the formula in here right now, Dr. Phil.
Yes. Yeah, sure. Y squared plus R squared. Y squared plus X squared equals R squared.
Or you're using Pythagorean formula.
Y squared equals X squared minus R squared.
Oh, so we're using Pythagorean formula. Cool. Let's do it with this one.
All right. So
let's do it with this one. We already got everything here. Right here. On this one. Let's do it. We're doing it with this one. So we're getting the radius from this photo right here. Let's do it. So we got an observer height at 1 foot.
We're not doing spherical trig then, John. We're doing.
You don't like to listen to the rest of this?
Well, you just said we're doing planar trig, not spherical trig. So why would we do that?
Fortunately, in fact, it's going to be a spherical. When you plot the distances, you'll notice that it turns out to be a sphere. And it's spherical.
No.
Shit.
You can't with the maths.
Why the fuck is he still talking?
Hold on. Let Adam at him. Let Adam at him.
You can't. You just described, as John correctly said, Pythagorean theorem. You can't use anything. Well, unless you can't steps, you shouldn't be using it, should you?
No,
how are you getting a ball from Pythagorean calculation?
I didn't use that, Adam. You don't know what you're talking about. Do you not know the formula for a circular function?
Go ahead.
Put it in live stream. No, so you don't go back on.
I'm thinking in whatever thing I was doing, if I was applying it over a ball, pi is going to be in there, and then there's going to be an R value. Whatever formula I'm going to say, it's not going to be, A squared is equal to B plus C squared or whatever. It's not going to be like that, is it? Because it's going to have to take into account distance, and the R value, isn't it?
Nobody
It's going to have to be proportionate.
No one said that, Adam. You just made that up because you don't know you.
Rate of change based on R. If we're going to describe any traversing across the sphere, and rate of change of R is fundamental in any formula, isn't it?
Oh.
No?
I'm just going to write the formula on the screen right now.
No!
If we're going to describe
why do you hate
this...
science?
Okay. Can you see the formula I've put down on the screen now?
What are the assumptions? Yeah, okay, lovely, Phil. So what are the assumptions?
No, lovely. What is it?
No, please describe. That's loaded
What is
full
the
of
formula that I put on the screen just now?
Loaded full of assumptions to derive it down to that. So I think it would be relevant if you're gonna if you're going to reduce it to that level, Phil, you need to ascribe the assumptions you make to that level. Yeah, that you're going to make it bring that down. So go ahead when you're talking about the Earth as a ball. What you do to bring that formula down to that, because that's naughty. Go ahead.
I told you that I would be able to use the that particular image to work out what the radius is. Now, right there in the formula,
I asked about the formula you're using to cite to back up the statements you're about to make. So please describe the assumptions for the derivation that you use to derive it down to that base level.
Listen to what he's saying, Phil. Stop interrupting him.
Doesn't there? If we're talking about the Earth, you've got to describe what you negate within that derivation.
No,
otherwise it wouldn't be. Otherwise, it wouldn't be so pretty, would it, Phil?
No,
we both know that.
No, I don't.
No, you don't. Well, I do. So clearly, once again, you demonstrate
you don't know what you're talking
you're
about.
at a much lower level.
No,
carry on. Of course I am. That's why I just pointed out the formula you pointed out to back up your bullshit. Yeah,
rubbish. You don't even know.
Assumptive.
You don't
and
even
requires you to negate
don't shut up.
Lots of the parameters in it for you to derive it to that. And I think you just should be honest when you're putting formulas up. It's a bit like with the assumption to the horizon calculation. You have to derive that it's negligible, certain components of it, i.e. the curvature, to get to that calculation. So, once again, with regards to yours, what are the things you have to consider as negligible and ignore? And I think you'll probably find it's rate of curvature, but carry on, Phil.
Okay, so you don't have to assume anything, okay? All you need to do...
You're already assuming R, because I've seen it in your calculation.
No,
I've seen it in your formula. There's an R squared in there. You're assuming it from the...
No.
Well, where did you get R from? Where did you get R from?
I can make that the subject.
No, you can't. It's already in your form. It's not R equals, is it?
You're not that sharp,
are you? Your equation. You can't make it the subject
to make R equals for you.
No. Go back to the initial waffle you were starting. It's in there. Where did you get the R from?
You don't need to get the R. You calculate the R.
You don't need to get the R. You just assume the R then.
No, you don't have to assume it. Not at all.
No, you don't need to get it. You don't need to assume it.
Exactly.
What does it come from? Archangel Michael? Does he bring it? Where do you get the R from?
I'm just about to show you.
That would be Gabriel.
Pictures.
No, Michael. It's well below Gabriel. Come on, where do you get the R from in your formula?
Show you.
Is it optics? Are you going to put a picture up? Show me a picture of something. After all we've just been through.
I know you have
that boat miles away and I can't see the bottom 10 foot of it. Is that what you're going to show me now?
Have a look at this.
Prove your R.
I've written down.
I can see He-Man. That says it all.
What is it? What does it say about the formula? I've written down.
Where?
You can't see it?
36 minutes after the hour. You're using Pythagorean formula.
That's not Pythagoras' formula, by the way.
Oh, my God.
So, like I asked them, Phil, if you're applying that formula to the Earth, you've rearranged it. Well done. Well done. Very good. Bag of shite. Okay.
It's Pythagorean formula.
It doesn't really matter. He just swapped his functions around. Scroll up a little bit, look.
Yeah, I know. I seen what he did.
Yeah, I see it.
Now,
sometimes just saying I don't know is the best thing to do.
Now, do you know where we get? Now, do you know where we get y squared from? Y squared is the height. Do you know where we get x squared from? X squared is the distance away from.
Oh, I already did that on the Black
What's
Swan.
R, Phil? What's R?
That's what he's solving for.
Exactly. At least there's one.
So I already did that on the Black Swan. Guess what I got?
Yeah, actually, going back to the point that optically you're going to use X and Y to solve for R, even though what we've just been through.
What have we been through? That's a problem.
With the Pythagorean, yeah.
It's not Pythagoras, by the way.
You can use Pythagorean formula on that, but you've got
not Pythagoras' formula
on a sphere, haven't you? You've got to place that triangle on the sphere.
It's not a triangle.
You've got to assume that the XY coordinate differences and any difference in there is caused by a change in the Y coordinate, isn't it? Yeah, based on curvature. So that's just absolutely shocking. There's some kind of evidence. That formula that you think that is any way supporting, it's just bullshit maths, mate. That's shocking. Should be ashamed of yourself.
Is that not the formula for the function of a circle? Yes or no?
Do you understand that Pythagorean formula is a squared plus b squared equals c squared?
I'll leave you to it for you.
I know what Pythagorean formula is. That's not.
That's it.
No, it's not.
You just have different variables: r, y, and x.
No, it's not, Huey. I thought you would have known better,
dude.
I thought
everyone could see it.
I thought
Pythagoras didn't even exist.
You guys, we should listen. We really need to listen to him, okay? Because he drives a really nice car. So I really think we need to listen to what he has to say. His car is amazing.
He's a professor. He professes things.
Are you still not able to get pretty girls even with a nice car?
A squared plus b squared equals c squared is not Pythagorean. What?
Yes, that is Pythagoras, but not this one.
You can replace the variables and just it's still going to say.
No, you can't. This is a different formula altogether. This is a circular function.
What's this guy, Mickey?
This is a circular.
It's not measuring. This isn't measurement of Earth curvature.
No.
I feel like we've been spinning our wheels here trying to figure out measurement of Earth curvature.
I've just given it to you. This is how you work it out.
Yeah. You gave me the formula. Well done. Like when are we going to go out into reality and measure this curvature?
Yeah.
Remember that image I showed you of that boat? How can we figure out a measurement?
Oh, don't worry. I'll work out how we can work out what that sea line is.
Do you know how do you know? Hold on a second. Let's get back to the original. Do you know how the radius of the Earth was first established and who did it?
I don't care, but yes, Aristophanes and also.
I'm sorry. Earlier today, you 10 minutes ago, you said you really care. You know, he said he cares about what he believes.
Hang on, Quantum's on a point.
I'm not a historian. I'm a physicist.
Yeah. Okay. You're a physicist. If you're a physicist, I'm fucking Mahatma Gandhi. Fucking.
I don't care.
Aristophanes, do you have primary documentation?
I told you. I already. That's the historical information comes from Aristophanes.
No, there is no primary documentation. So I just corrected your history. It wasn't Aristophanes, and no matter how you can overtalk me, that's okay because I'm just going to say the same thing with you muted.
It's also
Eratosthenes. Oh, who was that?
They did different things, you moron.
Also, apart from that, there's many other mathematicians.
No. Who established the radius of the Earth for absolute positive sure, and we have primary documentation of it?
Spell his name. Does it start with an A or an E? You keep saying Aristophanes or whatever.
No, it wasn't Eratosthenes. No.
Well, he doesn't know his own religion.
And how did Alberuni or Eratosthenes account for refraction?
Hold on a second.
Yeah,
Who's giving him clues?
Wow.
Now, obviously,
All right, I'm done. You take it. This is what I'm talking about. You need to shut the fuck up, right? But you can't do it. You just can't do it. Can't help yourself. So I'm out. Have a good one.
Phil, do you know how they supposedly got the radius? Yes or no?
I'm not a historian, but I know that Aristophanes used the sticks.
Okay, but he just now told you that Aristophanes doesn't even have primary documentation. There's no way to validate the historicity of that claim. It's just a story. So I'm not done talking, Phil. So for one, there's no primary documentation. There's no way to validate the historicity of that claim. In addition, according to your little religion brought to you by Jesuit priests, that's not even the person that actually established the radius. Did you not know that?
You can go and do this experiment yourself.
Okay, it's not an experiment. And in addition to that, we are not talking about what you think. We're talking about what your little religion claims. Now, they don't claim that Aristophanes actually came up with the radius. Did you not know that?
You can go and do this yourself.
Are you like a robot?
What's the difference between coming up with the radius and circumference?
First of all, that Aristophanes experiment would work the same.
What is the difference between? What's the difference between coming up with the radius or circumference?
Well, the supposed circumference, which again was just a fairy tale because there's no primary documentation, was much more vague approximation. They claim that they got a very accurate radius value with a different methodology. Do you know what that was?
I don't know I don't know the error that he made, but it would be around about 5%.
Don't you find it odd that you run around saying that we know exactly what the radius is, but you don't even know what the methodology was?
Yes, because our modern instruments to give us exactly what the radius is.
Oh, how do they do that?
Satellites.
Oh, yeah. So did you need the radius value to put a satellite into orbit?
That would be a good idea.
No. There's no good idea. You have to have it.
What for?
Well, you have to know the radius of orbit. I thought you did this for a living.
What?
And I'm a college.
Yes, I do.
What? Do you need the radius of orbit?
That's pretty obvious. Yeah, but yes, that's what I do.
Do you need the radius of orbit?
Yeah. So
that means you need the radius of the Earth, then, right?
This guy's a troll, man. He's a fucking troll.
Yeah, I agree, Leo. We're reaching the limit. We are reaching the limit. We still haven't provided measurement of Earth curvature. We're reaching over 2 hours already.
Yep.
No,
yeah, we're probably gonna have to part. We're probably gonna have to part ways, and maybe try again some other time, Phil.
All right, well, let me bring something real fast, Phil, before you get muted because people can't stand to listen to your stupidity. Phil, here's the deal, bud. You actually would need a radius value to even supposedly go into space in this fairy tale medium that defies natural law. So whenever you just say, well, we measured it with stop interrupting me, Phil. You're a little gamma male, okay? But you're not a special boy. You're not a special boy. You're not a secret king. You're going to stop interrupting me, dude. For real, okay? So to go to supposed space, you need the radius value because you have to know the radius of orbit, which means you have to know the distance from the surface to the center of a mass and the center of the Earth. This is objective. No one cares what you have to say about it. So whenever you claim to invoke something in space, you're actually begging the question of what's in contention, which is the R value itself. So you couldn't have gone to space if you didn't have the R value, which what that means is they objectively would have had to definitively establish the R value to even go to space. So how did they do that?
Many ways. And
well, let's
okay. I gave you already. I told you how they.
He's just going to keep waffling. Yeah. Hey, I want to point something out about Professor Phil. Right before this whole conversation started over 3 hours ago, I gave him the Globe Earther role. He had plenty of opportunities to post links to information about what he's talking about. But we've been posting information, and it seems like he just found the live stream voice text like 30 minutes ago while he just waffled on for 2 hours, and he wasn't even looking at the information that we were posting while we were talking about it. And he hasn't posted a goddamn thing except for a couple of equations. And so, Professor Phil, you should be embarrassed, bro.
And the pictures.
Yeah.
Oh, a couple of
He's an
pictures. A
ignorant.
couple of
He's
pictures.
just an ignorant, stubborn person who,
Wait, real fast. Let me say one quick
wouldn't
thing.
want to listen
Professor
to
Phil,
people.
Professor Phil, here's the deal, okay? Professor
Shut
Phil,
up.
listen,
I'm
check this
talking
out.
now. I'm talking now. Shut the fuck up. I'm talking now.
No. Good try.
Shut up.
You have
Okay,
no
let him respond to what I said. Hold on, let him respond really quick to what I said. Make it really quick. Make it quick.
Now, I gave you the picture of the actual Earth.
Oh my God! Here we go again.
Okay.
Go ahead.
Professor Phil, here's the deal.
failed.
Here's the deal. So, in order to go to space and to send this little Himawari up there and take supposed pictures, which only come every 10 minutes and it's based on CGI composites, but you're just a clown. The point is, you'd have to have the R value to do that, right? And so we go out and we test the actual Earth itself, which is the only methodology that would be sufficient to actually establish the R value, right? And we've actually falsified the R value because the convexity rate of terra firma necessitated by the R value isn't on the Earth. It's nowhere all over the Earth. So we falsify the R value. What that means is when they told us they went to space, they had to be lying because that would be an impossible task without the R value. This is skipping over the fact that it's a violation of natural law. Okay, so with the falsification of the R value comes the falsification of the entire model. So you might want to pump the brakes and coming in here and making a fool of yourself. If you choose to live in fairy tale land where you believe the religion crafted to you by Jesuit priests without empirical evidence, that's your own decision. But stop acting like you know it's real because you can't even establish the R value or respond with any specific contention or rebuttal as to our falsification method.
That's what I was telling you, Phil, when you first came, when I first talked to you. That's exactly what I was trying to explain to you. And it seems like we haven't gotten the measurement of Earth curvature. So, I mean, you've been here, and just like Helio Skeptic was saying, I mean, you had plenty of time to post as much information as you wanted. I mean, I knew you put that image in there.
Over 3 hours.
So, yeah, I think we're gonna have to part ways on this one. So
Miggy,
hey, we're not going to ban you, Phil, but we do other things here. I mean, I appreciate everyone being here. Listen, no, it's just.
Do you mind if I speak?
You're going to give one more statement. Go ahead.
Okay, so the reason, as I told you, the reason that I'm coming here is not to convince you of anything. The reason I've come here is to explain what I think, why I think what I do.
I know
not to change your mind.
I know that, Phil, but you're still you don't have a rebuttal to all this information that we gave you.
If you,
that's the problem.
Yes, I did. I rebutted.
Hold on. I'm gonna upload. I'm gonna capture the part that.
Is there anything you have that you think that I can't answer?
Yeah.
Why would the freaking RC boats disappear bottom first in that video, Mike?
That's right.
I just want to thought.
Right. So the first question that I was giving you, the measurement of Earth curvature, is the only thing I was concerned with that you would actually be able to give me. That was, I don't care about any other argument that you would bring into here, but so long as you're able to provide that information sufficiently, and I would be able to test for it myself by what you said, then we would have something. But it seems like we didn't get anywhere, Phil.
Maggie, I was listening in, and what he said was, Phil, hold on just a second. What he said was boats going over the curve. And then just like 30, 40 minutes ago, he said it again. He's like, boats going over the curve. But he didn't really post any information about, any observations he's made or anybody else has made. He really just freaking...
Right. That's what I'm interested in.
I got a question. I know you can't answer, Phil.
The whole fucking time.
This question, Phil. You ready?
Crazy.
Can you explain the magnetic field on a globe Earth?
Yes.
Sit down. Okay, explain it.
Okay, so the Earth has a core, inner core. So it's got an inner core, outer core, and the magma. So
when did they go to the core?
Bro, chill.
So like 1, 2, 3.
So basically, it's the movement between the cores, the inner core and the outer core that's caused by the rotation of the Earth. By the way, that causes current eddies, and it's these current.
Is it a permanent magnet?
No.
Okay, so do you know what the dynamo threshold is?
Let me just finish what I was saying.
Oh, you're speaking from ignorance.
If these eddies, because the eddies create a current. This current, in turn, creates a magnetic field because, as you know, a moving current creates a magnetic field.
Demonstration, please.
Yeah, what's the source? What's the source? Right. It's okay. We don't need to make fun of him anymore. Come on, man. This is over.
Let me say this, Phil. You're not here to share what you think.
Flat earthers too right now. I must be confused.
You're here to share what NASA.
It's because Professor Phil, we just don't.
We knew about the magnetic field long before NASA was ever.
All right, can we let Witsit finish his point because I was interested in that.
Okay. So actually, we have exact characteristics of a permanent magnetic field, but they say that it cannot be a permanent magnet because, of course, the Curie point and the dynamo threshold. So I have a Harvard article I can post just since you don't know what you're talking about. And they admit that they can't explain the magnetic field on the Earth. So we have what's called a dipole, right? But then we have an additional convergence point of the magnetic field, which of course, is impossible. This would be called a monopole, which is hypothetical, doesn't exist in real life. There's a fourth convergence point missing because you need dipoles to establish a magnetic field. This is well known within the top. Listen, this is well known by the subject matter experts in your own paradigm, but you have no idea what you're talking about. They admit they can't explain the magnetic field yet on the globe Earth.
No, they don't.
I will send you a Harvard paper that says that you're an idiot.
Go for it. And I'll call that guy an idiot.
You'll call the subject matter experts at Harvard, but you don't even know what the dynamo threshold is?
See if you can get some of my friends at MIT to say that.
What's the dynamo threshold?
How the hell should I know?
Can you prove a monopole?
There's no such thing.
Exactly. Do you know the problem with that? We have a third independent convergence point on the globe Earth. Did you not know that?
However small the magnet is, it will have two poles.
Yes, that's right. There's no way to have a magnetic field without a dipole. Okay, we have two poles, but then we have a third convergence point without the dipole, which means there would be a quadrupole. So they're trying to explain it.
No, bullshit.
No, nuh-uh. That's right. Nuh-uh.
That's fear. No. Oh no, that's cactus. No.
Show me.
Objectively, just to wrap this up. Objectively, here's the deal. The subject matter experts that try to explain the magnetic field using dynamo models. There's about 6 or 7 theoretical models that they're currently flirting with to try to figure out which one they're going to pick because they cannot explain the dynamo threshold, the characteristics of a permanent magnetic field. While of course it can't be a permanent magnet because of the Curie points, and so we have the dynamo threshold problem, we have the monopole problem, and the very top people in this field admit that it's a problem explaining it into the globular Earth. But you just seem to have the confidence and arrogance of consensus that it must be figured out because you don't understand your own religion, right? And I'm a college dropout. I must not know what I'm talking about. The point is they're trying to explain a monopole, which is hypothetical, doesn't exist in the real world.
No, the point is it's a question you couldn't answer. It was a question he couldn't answer, which is the whole point of that, right? You asked a question, he couldn't answer it, right? And by the way, I've spent the last 45 minutes listening to him try to explain gas pressure without a container, and all you do is ramble on about bottles, beakers, containers, and fish tanks.
Couldn't I answer?
All right, so I guess
is this what
right now,
Panda servers like?
Phil, you could probably just maybe go on mute so we can start talking to other people.
Yeah, coming on.
So we're gonna move on. So Phil,
time.
You could probably come back some other time or put yourself on mute, whatever you want to do. But we're gonna actually start talking to other people.
Watching 24/7 Flat Earth Discord live.
Right. Put a pause on that conversation.
I jumped in when you guys were initially talking about the gravity